Hey everyone, welcome on in. Happy Sunday. We're going to be continuing our lesson with some introduction to machine learning. We need to do a few items here on our list. We've got linear regression today. To complete it, we need to fill in these functions. These functions need to fill out right here. So we have not finished those yet. We got to finish those. We're going to build the training function, which we've partially started, but there's more to it. We need a calculator gradients, which is probably the most complex part of the whole thing. So we basically need to compare the features and all the inputs before, if we're doing a deep learning model, to the actual outputs. So we need to do a little bit of like math, basically. And then we have to scale it so that way we don't, create too much pressure on the training weights when we optimize them, right? And so when we're doing linear regression, this typically means that we are focusing on the output as a value, some sort of number. That's linear regression. So it could be like dollar amount, right? How much money you plan to make in the future, for example, right? If you're looking at on a line. With logistical regression, it's sort of a probability, like 0 to 100% chance, right? So today we're doing linear regression, which is a number output. If we finish this part here, hey, how's it going, Alex? Good to see you. Welcome on in. Happy Sunday. Good to have you here. Oh, hey, gloomy traffic over there. How's it going? You just wrote your name wrong. Oh, hey, Steven. Hey, good to see you. Welcome on as well. Good to have you here. We're going to continue. No worries about spelling the name wrong. That happens all the time. Don't worry. That happens all the time. You don't have to worry about it. So we have to finish. We have to write in these functions. And if we finish that, we could also, let me see here. We could work on the Titanic training data like you recommended before, right? Some Titanic training data. I believe we put that in here on a README. Yes. So the Titanic training data. So we can do that as well. So we'll be working on that. That'll be the plan for today. We could finish linear regression and then get lesson 7 going. That is a good plan for today, I think. All right, let's start filling in our optimization. Optimization's a lot easier. We need to do more with just the gradients. We should probably, because we need the bias, we need to optimize the weights and the bias. So we have to adjust these parameters here, which are the coefficients. You are going to say thank you for all the teaching you provide. Oh, you must be so busy and you even support your followers on the weekends. Yeah, hey, thank you. Yeah, gloomy traffic, absolutely. Happy to have you here. It's really exciting for me too. You know, it's a mutually beneficial. We learn together. It's actually a lot of fun because I get to talk to you and everyone else in the chat as well at the same time. And then sometimes you tell me about things and I learn new things. I do. It's such a great benefit. I think everyone should do this. You know, everyone should do it. It's great. It's fantastic. It helps me a lot. It helps me a lot. So it's really good to have you guys here. So thank you. You're too humble. Hey, great. Hey, thank you. Yeah, it's fantastic. I love it a lot. I appreciate it. Yeah, so we're going to have a lot of fun today. We're going to fill in these functions. It's going to be pretty easy, laid back, although it's going to get intense when we hit the gradient part. That's the part that it gets a little bit intense. So that's what we're going to do today. So let's see. We need to optimize these parameters here, the weights and bias. Since this is just a basic linear regression, this is only one layer, and it only has so many parameters. Hey, how's it going there, Heretic? Good to see you. Welcome on in. Happy Sunday, Heretic. Hi. Welcome back. Good to have you here. How are you? I'm doing great. Thank you for asking. We're going to fill in our gradients and optimization and the training function today. That's what we're going to do right here. We're going to finish our linear regression. And if we get that far and we're able to get we get our loss down to 0 or near 0, then we're going to add in some new kind of training data. We'll try to vectorize the Titanic data. So we'll see if that works. That'll be the plan for today. I think we've got plenty on our plates to take care of. So let's see. The optimization's easy. So why don't we start with something easy? Right? So all we have to do is adjust our weights and biases in our optimization. This is going to, we can subtract equal the values. We should also say self.learning rate, something like this. We could also pass in our learning rate here. Learning rate equals 0.02. of the default. There we go. And then we can use these parameters. Here, what I'm gonna do is I'm gonna go ahead and probably, should I close this so it's a little easier to see? I think I should, yes. I think I should. Brother, I have entry-level React JavaScript learning. Any tips, ideas in the level job? Please help me. Okay. Yes, let's think about that. All right. So with React.js, you're also going to want not only to know how to create like a component, right? Obviously, that's kind of like the whole point of React.js. Creating a component, a web component, encapsulated JavaScript, and maybe some styling and other things like that, all in one nice little component. You can reuse that component. So there you go. You've got a good starting point now. I would also recommend the backend. Now, if you're looking for entry-level job, the thing is, here's the trick. This is actually a really good trick. It's my favorite trick, and it's not really a new trick. It's a very old trick, and it still works today. You want, if it's based on your skill and your experience, if you don't have any experience, you're gonna need to get an entry-level job, which is not an engineering job. It's not. It won't be an engineering job. It'll be sort of like a tech support role or a data cleaning role or something like that, right? So data cleaning role, you want to search for those roles and look for a job that also has an opportunity to give you an engineering level role within a couple of years. There you go. That's the trick. It's the oldest trick in the book, and it works. It really does. That's all you have to do. It doesn't guarantee a job, of course, but it helps improve your chances a lot because nobody wants those jobs. Everyone wants the engineering job, right? Everybody wants the engineering. Hey, how's it going there, Awad? Awad, good to see you. Welcome on in. Happy Sunday. We're going to be filling in our optimization, our gradient, and training functions today. Front end roll, I have interest. Ooh, yeah, doesn't that sound good? A front end roll? Well, you can keep, there's a chance that you get lucky. There's a chance you'll get lucky and you will land a role. You apply to all the front end roles available. There's a chance. However, unless you have years of experience doing that prior, the chances are very low. So you're going to want to look for, some other subordinate type role that allows you to eventually lead into the front end role within a few years. So that's my recommendation because it's a trick that works. And you know what? Yeah, I did that trick. I did it way back in the day. And I can tell you it works. It really does. All right. So let's see here. Let's get into our optimization. We need to subtract equal something. We need to subtract equal our gradient times our learning rate. Optimization function's the easiest one. It's not as easy as prediction because prediction's pretty straightforward, right? Prediction, look at this. Single line. Optimization, we're gonna have to optimize these two parameters here. So we need to take our gradients, which are going to be our weights and bias gradients. So what we could call this, instead of say gradients, we could say like weight WEI weight gradients and our bias gradient, right? Those are what we're expecting. Hey, thank you for the hearts. Appreciate it. Welcome on in. Antony, hey, how's it going? Antony, hello. Welcome on in. Happy Sunday. Thank you for the hearts, you guys. Appreciate it. So we're going to subtract equal our weights and our bias gradient. These are assumed to be gradients, right? And we're going to multiply that by our learning rate. Learning rate. There we go. Boom, boom. I think that does the trick right there, right? I'm pretty sure. Thank you, guys. So good to have you here today. All right. Thank you for the hearts again. Appreciate it. Yeah, when you do the hearts, I could see the little floaty icon show up on my screen. Thank you. Okay. Yeah. Oh, I saw it again. Right there. I can see when you do that. All right, you guys, let's get into it. Thank you, Steven. Well, thank you. Yeah, absolutely. Good question. All right, so we just finished our optimization function, I think, right? Can it get optimized any further? This is like basic optimization. You could have a different optimizer. Steven La Blom. Hey, Sergio, welcome on in. Good to see you. Happy Sunday. We're filling in the remainder of our linear regression machine learning. The plan for today is to get our optimization, our gradient, and our training function complete. We're going to be doing that. The training is also going to be very big. The gradient calculation is the more complex part. So now that we've finished our optimization function, let's see if we can get into our gradients. Going to the tricky part next. I do have some notes over here, so I'm going to be paying attention off the side of the screen just a little bit. All right. So first we need to calculate. Let's see. We need our features. So we need the original inputs. So we need the original inputs. We need the targets, and we need the predictions, because we're going to be calculating the error, and then we're going to be generating our gradients based on the error. Hey, how's it going, the AW9? Good to see you. Welcome on in. Happy Sunday. Good to have you here. It's definitely a sign for me to complete the add folder in C++. Wait, what is the add folder? Wait, hold on. Wait, you got to explain this. AW9, good to see you. What is add folder? Here, what is add folder? I'm kind of curious about that. All right, so we're going to need our targets, our features, targets, and predictions, which is going to be the output from the model, which is the predictions, which is going to get it wrong initially. And then we know what the actual answers are when we're training, and we need to know what the inputs are. Augmented Dickey Fuller? I am not familiar with that. Let's take a look. Let's find out. Here, Google augmented Dickey Fuller. What is that? Fuller. I'm not familiar with this. Is it something school-like? The augmented Dickey Fuller, the ADF test, is a popular statistical method used to determine if a time series is stationary. Whoa, I didn't know there was a thing like this. Check this out. It's a test for the presence of a unit rot, which indicates that the data is non-stationary. Has a changing mean or a variance over time. Time series. Hey, Bonzupi, good to see you. You're going to go for 3 to 4 days and come back, Steven, looking for another 10 years longer. All right. Bonzupi, sounds good. So is that like a vacation? You're going to do like a vacation? That sounds pretty fun. Null hypothesis. A unit root is present, meaning that the series is non-stationary. No unit root is present, meaning that the time series is stationary. All right. So it's going to calculate a value output to let you know if there's a change or no change in the time series. All right. Sounds good to me. I like that approach. Here we go. Let's get into it. Oh, it's a perfect Sunday. Nice, good Sunday today. All right, let's get our gradients going. So in order to we need to calculate our error. We need to subtract our predictions from our targets. This is going to give us the error. No, you were already gone for 3 to 4 days. Oh, you're back. You're gone for, and then you came back. Oh, that's what it was. Hey, Rude Raw, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're currently building a linear regression model in our introduction to machine learning. We're going to make it work today. Today is the linear regression day, which is the precursor to deep learning, really. It's the precursor to deep learning. I mean, mostly logistical regression is, because you're doing classifications. So appreciate it. Rude Rod, thank you again for subscribing. Good to have you here. Share the playlist. Also got a code. Ooh, the playlist. The only thing is, this playlist is just a studio library playlist, which is not shareable. There's no link for me to share it. There's not. It's just YouTube Studio, right? It's YouTube Studio playlist. It doesn't let me share it. It's a good playlist, though. I really like it. It's a really good one. I like it a lot. All right. You are a gem, sir. Hey, Rudra, thank you very much. Appreciate it. Good to have you here. We're going to do, we've got a lot of plans over the coming years, you guys. We've got a lot of topics we're going to be focusing on. Lots of AI. We're going to go through more machine learning. We'll go through more deep learning. We're also going to learn Haskell. I've used Haskell like once, but not for anything serious. Just for fun, just to try it out. I'm like, whoa, what's going on here? We will be learning Haskell. We'll do more assembly. No worries, says Meat. Oh, all right. Good to hear. Oh, wait, I have a picture from inside a cave. No way, Bonzupi. Bonzupi. That sounds exciting. Share it in Discord. Share it in the Discord. All right. So we need to calculate our error, right? Got to calculate our error. Predictions minus targets. And then we need to create the gradients. So we need our weight gradients, W-E-I-G-H-T, weight gradients, and we need our bias gradient. And we do that by taking the error and multiplying the inputs, I believe, right? So our inputs, which we need to transpose over the error. Can I see that? Yeah. And then we need to average it because we're going to do a mean squared error. So error, and we need to divide by the number of features that we have, the number of classes basically. And that will give us our weights. And then we need to get the average of the error for our bias. Error, here we go. What's that? What loss are you using? This is mean squared error. So we're going to be using mean squared error loss. So this will be mean squared error. Although this is really the mean error. We're really doing the mean error. That's just mean error. It's just the average error over the set. So you can do a batch, right? So when you throw samples through your model, this will be a batch. So it's like a bunch of models all together, and then you average them out, and that becomes the error. Yo, hey, for the gold coin! Pixel Pal, thank you, Pixel Pal. Hey, that's very nice. I appreciate you very much. My gratitudes to you. Oh, thank you so much. Pixel Pal, wait, what's going on over there? Hey, thank you. That's like a nice little Sunday gift. You have to do that. Thank you very much. I appreciate it. Good to have you here. All right. Oh, while loops await with the meta trust. Oh, Adam 3. While loops without weights is the meta trust. Wait, are you having like a potential for an infinite loop is what you're describing? Oh, do you think mean squared error encourages model to predict this average answer rather than the most useful one? Yeah, it is the average. Yes. Yes, that is exactly what that does. Yes, that's exactly. Gloomy traffic, that's exactly what it is. We're just calculating the average. That's what we're doing. Adam 3, that was a joke? Oh, while loops without weights is the meta trust. It was a joke. Oh no, sad flower. All right, I did. I missed the joke, sir. I missed the joke. I didn't see it. Absolute error. Oh, can we do that? We need to do error.mean. We have to do error.mean, I think, right? Let's see here. Yeah, error.mean. And we have to say that it's on because it's a batch, we have to say the access is 0. How much of today's hallucination problem do you think comes from optimizing the wrong loss function? It's all of it. All of the hallucination comes from optimizing the loss function. Mean squared error. I would say most of it, yeah. Most of it. Gloomy traffic, you're on the right track here, aren't you? Hey, how's it going there? Mahend, hey, Mahender, good to see ya. Happy Sunday, welcome on in. And Tugram, hey, Tugra, hello. Tugra, good to see you as well. And Derek, hey, Derek, Dina, you guys, Dina. Derek is Dina. Hey, Derek, good to see you, welcome on in. We're going to finish our linear regression today, you guys. We're gonna do linear regression. And we need to we just filled out our optimization function. We are also going to finish this gradient function, which I believe we're very close to finishing really quick. And then we're going to create our training function, which we need to use our optimization and gradient functions and our prediction function all in one. If you could replace it, what would you use? Well, the best function that we do today is, what do you call it? Cross-categorical entropy loss, right? So cross-entropy loss, which penalizes the too many repetitive things, I think. And just some penalties there. It's got some let's look it over really quick. Let's look it up. Hey, GCA, good to see ya. Saw your comment on Squirrel Sniper's channel video. A huge large language model jargon cluster vibes. Yes, huh? You think? There's a lot. There's a lot in there, isn't there? Like nothing concrete seems to come out of it. What are your views? Here's the deal. Squirrel Sniper definitely uses a lot of words. However, Squirrel Sniper very often helped me on the channel and corrected some of the things that I did. And he was right. Squirrel Sniper was correct. So I tend to believe that Squirrel Sniper has quite a bit of real knowledge. I tend to believe. Do you speak English? Yes, Lawrence. Hey, Lawrence, good to see you. Welcome on in. Happy Sunday. We need to Google something really quick. Let's Google cross entropy loss really quick. So that way we can share this information with you guys. Absolutely. Man, how you add subtitles on live? Nova! Hey, Nova 007, how's it going? Good to see you. You asked the right question. So I've got these subtitles right here, open source, available for you for free. It's technology that I made many years ago, over 8 years ago now. 8 years, you guys. 8 years ago. Way before vibe coding happened, you can add subtitles into your live streams. Like this. If you want, you can have it too. It's available. Hey, Catmaster! Hey, how's it going, Catmaster? All of your cat comments. How do you like cats? I saw those. It's good if you speak English because it's good if you speak English because I don't speak English. Oh, all right. You fall Portuguese. Oh, Portuguese. Okay. Catmaster, good to see. I like cats. There we go, Catmaster. That's what I was looking for. You have a weird obsession with AI errors, RAG failure, API errors, gloomy traffic. You're on the right track. So let's go back over to this, you guys, real quick. Let's take a look. All right, where did we pull that at? Do we pull this over cross entropy loss? Here we go. Crazy man, it's too accurate, isn't it? It's good. It's really good. It's like, wait a second, that's suspicious. Whoa, it's too good. It's too good. I know, right? It's magic. Lawrence, you don't speak English. No, you speak a little Portuguese, Bonzupi. Nice. All right. Most of this content's like Reddit conspiracy theories. Yeah, it is, GCA. It really is, isn't it? That's why I didn't trust it at first. I didn't trust it. You know, small bit of coding, not gonna lie. Nice, very nice. Are you guys familiar with cross entropy loss? Yeah, you like that? I do. I really like this. This is what we use with the large language models. Yep, cross entropy loss. A standard machine learning metric used to measure the difference between two probability distributions, the model's predictions, and the true labels. You can do this. It heavily penalizes confident but incorrect predictions. That's what I was looking for right there. There's a penalty built in. Heavily penalizes it, you guys. In the use of all your accounts, you know, only follow 3 on one account? No way! Catmaster, that's fantastic. That's very, very heartwarming. Could you please say Tuesday, January? Tuesday, January. All right, there we go. Tuesday, January. You know about the Google News? Started to ask IDs for open source devs. No way. Really? Really? That's kind of what are true labels? The answers. True labels are answers. So you gotta say true labels equals answers. Basically the answer. So basically you've got a question, which are a set of facts, right? Facts / info stats, which is the inputs. There we go. Hey, how's it going there? Abhin. Hey, Abhinav. Good to see you. Welcome on in. Thanks for saying hi. All right. Every account I have has no one subscribed to it. Whoa, Catmaster. That's amazing. 2 + 2 = 4. The number 4. See? Right there. The number 4. 4 is the answer. All right, I have a few cave pics on the Discord. All right, let's check out the Discord real quick. Whoa, Bonzupi! This is like ancient caves. Whoa, stalagmites versus a stalactite. What's the difference? Whoa, is that a pool of water? No way. That's cool. It's like it looks like a very moist cave. Abhinav, hey, thanks, man. Yeah. Is the subtitles AI? Yes, it is. Unhinged. This is artificial intelligence on the subtitles. Yep. Right here. Some AI on the subtitles, you guys. Right there. Subtitles with AI. That's how you do it. That's the best way to do it. It flooded? I was wondering about that. You're reading it. I know, Abhinav. I'm reading it. Nice. Very nice cave pictures. Want to know something mind-blowing? Okay, Catmaster, do you like cats? Is that what's mind-blowing? Is it? At this point, I'm convinced my coffee is the real optimizer. Nice! I remember I used to drink coffee. I remember those days. I remember. What are you talking about here? Abhinav, we are building our linear regression with our Introduction to Machine Learning course. This is day 3. We are focusing on linear regression today, which is the precursor to most of AI models. It has the primary features and functions that you would use in deep learning too. You've got your training function, you've got your gradients calculator, you've got your optimizer, which is going to adjust your weights, and you've got your prediction, which is the feed forward. You stopped drinking coffee. Why? Because I got crazy. Because I got crazy. So I stopped drinking coffee because it was too much. So do you drink decaf? I drink water now. Here we go, you guys. This is what I drink now. This is it. This is the only thing I drink. Hey, Rockin' Brain. Good to see ya. Welcome on, you guys. All in 1K accounts. One Catmaster is my only account with 3 people I subbed. No way, Catmaster. All right, so my mind is blown. My mind is blown, you guys. So we're gonna do this today, you guys. We're gonna building all your own AI. That's right, from scratch, all our own AI using the NumPy lib, of course, so that way we don't have to do a little bit forward loop, right? So we get some of this nice little syntax. So you drink too much coffee, tea, you need to, yeah, you gotta be careful. You gotta be careful. So here's what I did with coffee. Are you guys ready? I took, you know the blender? There's a coffee blender. I took the beans and I filled that coffee blender up to the limit of the roof. And then I ground the coffee until it was like a fine powder. And then I'd put it into a single serve drip. And I'd pour that drip over it. And then I'd create a really thick, opaque coffee that I'd drink it slowly throughout the day, 1 cup. But apparently that was like enough for an entire pot. I would drink the entire pot in a little bit of coffee. So I had to stop doing that. What about green tea or herbal? Yeah, no, I avoid caffeine now at all costs. All cost, any caffeine. All cost. It's 11:59 at midnight right now, Catmaster. That's pretty late. It's 9 a.m. here. It's 9 a.m. in the morning. Have you ever built an earlier advanced AI with no restrictions? We do, yeah, because you have to do extra work to add restrictions. You have to do more work. And all of my models, I did not do any restrictions at all. Hey, how's it going there, boss? Oh, Vicus. Hey, Vicus, good to see you. Thanks for saying hi. Good to have you here. Yes, I'm serious. I am. 9 p.m. here. Nice. All right. That's pretty late, you got. Well, 9 p.m. is not too late. That means you're exactly 12 hours ahead. Whoa, Abhinav, you're 12 hours ahead. That's crazy. Hey, Razili, good to see ya. Why did you stop drinking caffeine consumption? Because I drank too much and it made me crazy. And it had consequences. Right? You go, it makes you crazy. You can't. So I've been doing that for like decades and it catches up with you. Apparently you have to stop after a while. I'm in my 40s now. 11 a.m. here. Hey, Bonzupi, nice. You're 3 hours ahead. You still good at Quake, the game? Hey, Ask Hayes, how's it going? Welcome on in. All right, so those of you who are new here, thank you for joining in. My name is Stephen Blum. I am the CTO co-founder at PubNub, which is my company. Started with Todd Green, my co-founder, many years ago now, over a decade. We raised 134 million. We're at Series E. We're still running the company right now. It's still active today. We have over 1 billion devices on my network right now and lots of patents. I've got a lot of patents. You can see all my patents on my LinkedIn. They're right there. You need to know what's the wildest thing you did on coffee? It sounds like you were going to have yourself a heart problem. Yeah, exactly. Exactly, Gloomy Traffic. We got to be careful of coffee, you guys. Whoops, ignore that, Adam. Okay, sounds good. Are we on exact opposite sides of Earth? It looks like it. We are. 12 hours exactly. How do you have subtitle live? Hey, DRK, good to see you. Welcome on in. It's technology I wrote 8 years ago. Using my technology, PubNub, which is a communications technology that spans the planet. We've got data centers in all of Amazon's regions. You connect to the closest data center with your phone and allows you to have an API to do built-in app communication. Things like multiplayer games, sporting events, anything telemedicine, e-commerce. This is what I do. This is my job. This is what I do. I'm gonna check out the patents. One of mine blown. Hey, all right, Catmaster, sounds good. Why do you have those weird line numbers here on my screen? This is my text editor. This is my text editor, you guys. Can you give me a job? Absolutely, we've got a job available for you. So if you scroll over here to our careers, where is it at? Careers, do we have it on here? Yeah, here it is, careers. And we look around here, we've got some open jobs for you guys right here. Let's zoom in on that so you can see a little bit better. Here's our jobs available, you guys. See, I'll pin this tab here. Friends. Yeah, Abhinav, friends, let's do it. Let's be friends. The wildest thing, is this a self list of variable tables? This is AI. We're doing AI right now. How's it going there, Con? Wait, Cone on the bricks. How's it going there? Or is it Con Eon the bricks. Yeah, Mr. Blum, do you see Bow 1, Bow 2 port to PS5? I don't know. Wait, what do you mean? What is Bow 1 and Bow 2? I don't know. Thank you for asking, though. Why does it not count from top to bottom? Oh, because it's relative, right? It's relative. So I can see how many lines above and below where my cursor are, right? It's relative line positions. You're cool. Well, up enough. Thank you. Mind bone, bro. Auto-correct. Okay. Right, but you would have to call it from somewhere, though. Atom 3. Wait, hold on. Let me scroll up. Where are you talking? Atom 3. Whoops, ignore that. I missed your context. You would have to call it from somewhere, though. Okay. Well, all right, you guys. Thank you for joining on in. Yes, so we do have some jobs open here if you're interested. We've got a Rust engineer. We've got a corporate counsel job. We've got customer lifecycle marketing, solutions marketing manager, and a couple other things in here. Hey, Show, thank you for the high five. Appreciate it. Welcome on in. Happy Sunday. My gratitudes to you. Thank you so much. High five. Appreciate it. Thank you so much. That's all I can. Thank you. I appreciate it. I have very high standards, not gonna lie. Hey, Cat Master, it's good to have high standards. It means our expectations are high. That means that you have opportunity to recognize what is good, right? It's your special ability. It's your special ability. Hey, Steven, you're still in university when you came up with the idea, Tech Foundations of Low Latency Communication? I was not. I was in Silicon Valley. That was after college. I was in my early 20s, really early 20s back then. Super early 20s. Early 20s, you guys. And we needed a way to add communications, and there was no good way to do it. So I'm like, I'm going to invent a way to do it. And I sure did. I invented it, you guys. I made it work. It's called PubNub now. And that's where we're currently building and adding even more tech. You have very low standards now, Show. Oh, no. How do you know what data has the best true labels? You need to validate it. You have to validate it. You need to know if it's real or not. You got to validate it. Asian time zones, Catmaster. We're in the US time zone over here. How can I contact you? Discord is a good way. Instagram or LinkedIn works. So you could do, you could go over here. I'll throw this link on Discord really quick under our link share. Link share, you guys. There you go. If you want, you can visit me on LinkedIn or just Discord direct message if that works too. If you guys are interested, Discord direct message works. Okay, let's fill out some of this code, you guys. Let's continue. That's impressive. I've invented something. Oh, you did too? You did too? Gloomy traffic. Tell us what you invented. You'll check them? Nice. All right. Nice, Catmaster. Linear regression, AI probability. Yes, you got it. AI properties. I'm probably wrong. It counts. That is, you're right. You're probably right. Linear regression, you guys. All right, let's get back into it. Let's do some more linear regression here. So we just calculated our gradient. So we need to return our weight gradient and our bias gradient. So we've calculated the error, right? Get the error. We've got our, a medical device. Oh, it went virtual. Ooh, medical device. Really? No way. Hey, Rox, how's it going? Just had dinner? All right, good to hear it. We're getting our gradients going. Hey, Rox, thank you very much for this function, the generate data function. We are actually going to we're using it. Happy Sunday. Thank you. Thank you. We're using your generate data function. It works way better than the one I wrote. What are other hobbies you have? I like video games. I play Minecraft. I play RPGs. I play farming simulators. I play, what's that called? Stardew Valley. I like Starbound. That's a good one. Terraria. I like those kinds of games. Hey, how's it going there? Real. Hey, Real. I'm an amateur game developer. Ooh, nice. You're doing the thing I wanted to do. I wanted to be a game developer. I made some games. I never released them. Roblox don't have any motivation, and I don't know where to start. Oh, how to start. I have a lot of ideas. How do I start? All you have to do is just go. Don't prepare. That's really critical. Don't prepare. Just say, hey, I'm going to do this now. And then you go to, a search engine like maybe Google or something like that. And you ask, ask the search engine, how do I start? Let's do this together. Let's do this together. All right, so Google Roblox. I want to build a game in Roblox. How do I start? All right, it's going to tell us. How do you make your first game in Roblox? All right, so there's a 30-minute video. There's a 9-minute video, which I recommend. I like the shorter videos. You can do that really quick. There's even a shorter one, how to make a game in Roblox. And just watch that really quick and then do what it says in the video. Don't stop. Don't wait. Just do it. That's the key. You got to do that. It's very important, you guys. Very important. Are you self-employed? Technically, yeah, because it's my company. So we have over 100 employees, which is pretty good. I think it's a pretty good sized company. We're doing all right. We're doing good. Oh, hey, Rutik. Hey, Rutik over there on Twitch. How's it going? How about creating an open source game for your next YouTube idea? Yeah, all right, Rutik. So we are going to be making an open source YouTube. We're going to make an open source YouTube starting Tuesday, I think. We're going to start that on Tuesday. Roblox is kind of a bad sub situation right now. Oh, is it, Catmaster? Really? I didn't know. Google me Dr. Almas Ahmed. Okay, sure. All right, let's do this. All right, Google Dr. Almas Ahmed. All right, is this? Wait, Gloomy Traffic. Who? Wait, is this you or is this? Who is this? Research. Wait, that's me. No way, really? You can't be serious. Really? Oh wait, you tried to connect to me. All right, I'll click accept. Whoa, no way. Yeah, that's crazy. No way, that's great. Here, all right, so I'll say hello. Hello. Thank you for connecting on LinkedIn. Oh, I spelled that wrong. LinkedIn. let me type that around. That's great. All right, let me click edit really quick. LinkedIn done. All right. Hey, Gloomy Traffic, we're connected now. That's crazy. How do you calculate your gradient bias in the AI? So I'll show you. Gloomy Traffic, that's great. Now we're connected. So in order to calculate, you need to get the error first, which the basic error is just subtracting your outputs from your model, which are your predictions. That's part one. From the actual answers, your targets. So you just need to subtract them to get the absolute error, right? The exact error. Then you need to scale that error. You have to scale it. So a good way to scale it is to average it over the features. And you have to do a pass through on your features with your errors, so that way you know what the inputs, which you're going to calculate the actual gradients. So this is the actual gradient calculation here, and then you scale it by the average of the features, by the number of features. You replied black on LinkedIn. Hey, Gloomy here. Hey, you proved it. Hey, nice. Great to have you on the lives and your adventures. That's great. Hey, Gloomy Traffic, that's fantastic. That's very cool. Good to have you here. You did. It's proof. We really know it's really you. That's crazy. Current being moved up to Supreme Court. Oh, wait. Oh, with law by Mike? Oh, Catmaster, no way. Hey, how's it going there, Real? I'm thinking of taking up a computer science for your GCSEs and getting a job that kind of field. You should do it. You should do it. I think it would be great. Oh, by a lot of angry parents. Okay, got it. Yeah, you got to be careful with that. I could see. Total number over total searches equals average. Total number over total. It depends. Adam 3? I think so, yeah. Yo, hey, thank you for the laughing disco. Real, hey, Real Angel, hey, thank you. Appreciate it. Happy Sunday. Good to have you here. Or just thank you for my gratitudes to you. You guys are wonderful. You guys are so nice. Thank you so much. Thank you very much. So yeah, so we need to take that. We need to grab our gradients by taking the error and doing a filter through our features with a matmult, and then we divide by the number of features we have to scale it. And then we take the error, which is going to be as simple as this is like the easy version, right? This is the easy version because our bias is just a scalar. our bias is a scalar for each class on the output. So it's a scalar, which means it's a single number, right? It's a single number here. So it makes it really easy to deal with, like really easy. Super simple, super simple. And then we return our weight and bias gradient mean error. So it's not the mean squared error. We're just going to be sticking the error and allowing us to divide. We're going to have a higher learning rate, basically. We're just going to increase our learning rate. So instead of a number like this, we will have a number like that. That's all that means. Real simple, really easy. Thank you again, Real Angel. Appreciate you. Thank you for answering everyone's questions. Oh, and the advice you give is amazing. Hope he becomes like you one day. Oh, hey, thank you. You've earned my sub. All right. Thank you very much for subscribing. I appreciate it. Good to have you here. Yo, Chandra, how's it going? Chandra, you guys. Chandra, kind of below the amateur rank in programming. Don't worry. Don't worry. There's always something more to learn. It's a forever thing. Like there's things that like I'm still learning, and it'll be forever. I will still be. It's a lifelong learning journey. You guys, it's a lifelong learning journey. All right. So we've got our gradients and we've got our optimizer. We've done those two things. And we were able to do that in the last 40 minutes, which is pretty good. Now we need to create our training function. Now we need to do our training function. How does it decide to pick when returning errors? It's always a thing. You always do it. Hey, Real, thank you for the silver star. Appreciate it. My gratitudes to you. I very much appreciate it. You're so nice to me. I like the silver star, right? Look at the silver star right there. It's a good silver star. I like those silver stars. Need to sleep soon? Oh, it sounds good, Catmaster. For the pre-test in your programming class. Hey, very nice. You're gonna do great. You're gonna do great. Just it's a slow and steady adventure, you guys. It's slow and steady adventure. Okay, so now that we've calculated, wow, great. Your username gives a totally different vibe. Yeah, gloomy traffic. I know, right? I know. Your profile looks not gloomy. Looks very sunny profile. Making progress in making games. Nice, Catmaster. You're doing what I want to do. I like making games. That's what I did in high school. I made video games. All right. So now hey, Retro, good to see you. Welcome on in. Happy Sunday. Good to have you here. Adam 3, what languages do you recommend learning? Every type? Everything? Yeah, I learn everything. I mean, here, let's go through it. Let's go through the language. The ones that you want to learn in industry. Industry languages to learn. You're a very happy person in real life. Nice. Industry languages. You're going to want to learn JavaScript / TypeScript. These are good ones, right? TypeScript. Then you want to learn Python because that is very common in the data science world. So that's very big. You're going to want SQL as a domain-specific language. Then what else? Also, if you want to go a step further, you're going to C++, Rust are going to be more systems level languages. These are going to be more heavily computer science oriented and quite a bit more effort. And then if you want to go middle of the ground, you can do Golang. Golang's a good option, right in the middle. A little bit of a good option right there. Yami 2, nice. Online alter ego clinical. That's awesome. Math is very easy, not gonna lie. Math is pretty good. You recommend doing C, but it depends right on the Python, no matter what else you want to do, since back-end, front-end supports. Yes, and then you're also gonna want to learn HTML and CSS. This is at the easier end of things. It gets a little bit more complicated here. And then Python SQL for data, right? You want to do data aggregations. Aggregation. Feels like a word that I should know how to spell properly. Let's do this. Google. Data. Whoa! I didn't mean to do that. Google. Yeah, there we go. Aggregation. All right, we spelled it correctly. All right, that's good. All right. Hey, Stephen Bonzupi. That's going to be syntax error. Yeah, it is. You think? You think that's going to be a syntax error? Just a little, if we throw comments around it, it won't be, right? We could do a little bit of commenting here. There we go. Comment. There. Now it's not a syntax error. We took care of that. E equals mc squared means energy is mass squared, right? Energy mass squared. Hey, let's go in there. Seraphim. Hey, Seraphim official. Seraphim. Still don't know what. Oh, wait. How you very motivated from age 11. Hey, you good memory. Yeah. Age 11. Sam's teach yourself C++ in 24 hours. Sam's teach yourself C++ in 24 hours, which it definitely was not 24 hours. It was a little bit more than that. It was definitely a little bit more. Your innocence is gone. Oh no. Hey, don't worry. It lasts forever. You know, Bloomberg didn't really get started until his 40s. So you have, there's so much opportunity. You don't realize how much opportunity you guys have. It's just amazing. You're going to change your profile pic? Is it going to be a cat? I'm just guessing. I'm assuming. Learning Lua. Hey, Lua. Nice. Lua is a great language. I should also mention Lua would be a really good one to add into your list here. Lua is great. Definitely add Lua. Probably start with C and Python. Yes. Yeah, if you're being serious, those are two good combining language. Energy equals mass times the speed of life squared. So, or is that speed of light? Light, L-I-G-H-T, or life? Wait, if it was life squared, okay, light squared. Okay, I thought life would have been a little bit more interesting, actually. How much time does it take to learn coding language from scratch? If you're really focused on it, Chandra, if you're really focused on it, you could do this. You could get the basics down in a couple of days. You really can. You can get your basics down in a couple of days, right? So if you really wanted to, I mean, you just need to learn basics, right? Python, you'll say variable assignment equals 100, right? You get the value of a. You can say a greater than 10 will turn back a Boolean or not. A less than 10 is false. And then you can create logic gates and logical coding, right? So there's a lot of things you can do, and it does not take that long. Don't let anyone scare you out of it. Do not let anyone scare you out of it. If it's life, that's a deep philosophical question. See, that would have been really, right? See, I think that would have been great. What keep you motivated? You guys do. Seraphim official. It's because you guys are here. Also, I have a curiosity. So AI is one of my favorite things, and I really love spending time on it. It's just very challenging. It's very challenging. How much time? Let's see here. I changed your profile pic. Hey, there it is. I'm going to take a look. Let's take a look here. All right, let's get into it. Go to channel. All right, let's take a look at your picture here. Yeah, that's a cat right there. Look at that. Hey, Cat Master, you found yourself a cat photo. It seems appropriate. It fits your name. It fits your name. You did it. You did it, Cat Master. Yeah. So motivation comes from, you got to eat healthy. I would say that's a big part of it. Most people don't. It's got to be fresh vegetables, fresh fruits, beans, grains, and seeds, berries. That's it. Don't eat anything else. Only water, and your energy stays really high, and you're going to be in a really good spot. So, surround yourself with cat photos. That also works. Eat healthy, sleep well. Sleep well too. Yeah, it's a good idea. I do that. I sleep from 7 p.m. that's my starting bedtime, and I wake up at 4 a.m. So that's my schedule. Python functions and the different data structures. What are then next things to learn? Oh, actually, DRK, that's a really good point. So you've got, you know good enough Python, like the functions and the different... Are you familiar with Dunder methods? Are you familiar with Dunder methods and list comprehension? Dunder methods and list comp. Those might be a good next step to go into. I do that if I don't work late. Oh, nice. Yeah, me too. Always sleep 12:45. Still wake up energetic and happy. Nice. All right. DRK, you're not? Okay. So I would recommend those. Those are good next ones. So they're fun. I like them a lot. All right. So now we've got our gradients. We've got our we created our gradients, we created our optimizer, we've got our prediction feed forward function. We've got our loss here that we're only going to use as an output to show us where we currently are on the model. And then we need to run our training here. So let's do our training, you guys. This part we have to do right here. All right, so we're going to need our gradients. So we're going to get our weight, our grad. How should we do this? Grad for our weight. Maybe we call it weight grad. I think it's better. W-E-I-G-H-T grad, comma, bias grad, equals gradients. And we want to pass in all of our variables like this. There we go. There, our gradients are calculated. I sure hope it works. We're going to find out. We're going to find out. I just collapsed from exhaustion around 7. Nice. Yeah, I often just fall straight asleep pretty quick too, because usually it's very busy in the day. Oh, you know the list and the list function's basic traversal, like the data types. Nice, DRK. Excellent. To be honest, I have 2 games I made, but they are failed projects. Hey, they don't have to be fails if you make them successful, right? You could keep going. You could keep going. Wouldn't bias grad be nil? Would it be? I don't think so. We're just taking the error and then we're averaging the error across all of the samples. So it shouldn't be. It shouldn't be. Let's print it out. Let's print it out. Print our weight gradient. We should also spell this correctly. W-E-I-G-H-T. There we go. Weight grad. And did I spell this one here correctly? Yeah, that looks good. That looks good to me. And then we'll go our weight gradient. And I would like to throw an F string around this so we can see exactly a little bit better. Then we'll get our bias gradient here. There we go. And print those out. I'd also like to print the loss like this as well. So let's do a little bit of loss calculations with our pretty printing there. What are you coding? Hey, Dragon, good to see you. We are building linear regression today. We're going to finish the introduction to machine learning that we planned on doing here. Let me clean this up really here. Some old industry languages. There we go. Okay. Thank you for the hearts. Appreciate it. Yeah, so we basically did an introduction tutorial for machine learning. Over the past 3 streams, we did the basic tensor math, very basic tensor stuff, which is basically arrays, numbers, right? And now we're doing linear regression, which is the precursor to deep learning. That's what we're doing today. We have calculated our gradients successfully. I think we need to test it out. We're going to test it out right now. Our optimizer is easy. I know that's correct. The optimizer looks good to me. So we're good to go there. You'll be a big channel soon for sure. Whoa, Chandra, thank you. Catmaster Party Popper. You guys are so nice to me. Thank you. This is great. All right, so let's keep on going. So this is a mean error. Oh wait, this is update our weights, our parameters is what we want. Update our parameters so the model can learn, right? We're going to teach the model. We're going to teach the model how it works. You got Instagram? I sure do. I sure do. I'll put it on our Discord, you guys. So that would be Stephen Blum Code on Instagram. Here we go. We got Stephen Blum Code right here. Right here. We're almost at 11,000 followers, which is kind of neat to see. Wow, we were only at 10,000 just a couple days ago. Let's see. And then I'll put that on our Discord, you guys, under link share. There you go. So if you're interested, there's IG and LinkedIn. Which IDD are we using? Sanjay. Hey, Sanjay, thank you for asking. This is Vim and Tmux. So we got Vim and Tmux here. Vim, Tmux, and Ghosty. So I'll type that in the chat here. Ghosty plus Tmux plus Vim. Chandra Stephen has been on the platform since 2011. Yeah, yes, I have. Let's see here. Which one? On YouTube. Yes, probably on YouTube. YouTube. Wait. Steven. Here we go. All right. Does it say number of years? It's got to say that around here. Yeah, since 2011. Hey, you found the number. Yeah, that's right. So that's like the early days, you guys. And I just didn't do anything. I just held my account, and then suddenly I decided to start streaming, you guys. All right, so where are we here? Let's go back over here. T-Mux and Ghosty, Vim, hey, Zergio. Got that Vim in there. I like Vim. Vim is my favorite. Vim heart icon. There we go. Oh, that's 1 year after I was born. All right. You guys, if I had to be honest, you've been watching you code for weeks just to see what you do? Whoa, Catmaster, no way. Hey, we're going to be building some neat things. So tomorrow we've got a plan. We've got a plan for tomorrow. We're going to have a guest speaker. One of my team members, one of my employees, a DevRel engineer at PubNub, will be giving you an overview of AI agents, and we're going to use OpenClaw. We're going to be using OpenClaw tomorrow. So that'll be tomorrow's plan. So tomorrow will be different than the other days. We'll have a little bit different day tomorrow. Until the day I chatted, can decide to sub. Hey, all right. That's the day. That's the day it happened. Oh, hey, Rox, Steven, do you like fame? I feel like being famous forces us to live different life, but not if is the goal like actors. I would say I would rather play video games and just sit in my chair and play video games. That's why I grew up. That was my goal. My goal was, hey, I'm going to create businesses, and then I'm going to make enough money so I can just play video games for the rest of my life. However, it turns out when you have a good business, it takes even more of your time. It takes even more of your time. And so all that time that I would be playing video games, it turns out I'm spending on my business. And I kind of like it. I think it's pretty great. I like doing business. You have a strict schedule when it comes to school time. Nice. Yeah, that's actually a really good idea to do that. All right, let's see. Let's run this, you guys. So Python. Let's see if this works. Python lesson 6. Here we go. All right, then we have to run main. Here, main. All right. Hey, look at that right there. Although our weight gradient might need to be boosted a bit there. Let me see here. 1 second. Let's try that again. All right. So it looks correct, and our bias gradient looks correct, and our loss looks correct as well. Let's try that again. Yes. Okay. All right. So I'm seeing good initial numbers. Watch you from next year for sure. All right, because I'll get into university next year. All right, that's great. Hey, you're on the right track. Fantastic. You don't understand a thing, to be honest. It's my first time looking at code. Whoa, Chandra. If you're really into it, hey, it'll become second nature. It becomes second nature. Also, here's the deal though. We do have these tools called generative coders, right? The agents, the AI agents that generate code for you. Don't get too dependent on those if you are very serious about being a software engineer. I think, although I could just be biased because of my age and my experience has been in writing code by hand. It has been. Although if you were to take someone who does know the entire code in and out, and then you take someone who doesn't and can only vibe code, which engineer would you choose to join your team? I think that's something that we might think about, although I could still be wrong. I could still be wrong about that. Hey, Mark Lemon, good to see you. Happy Sunday. Welcome on in. Hire you. All right, yeah, I'm the colonel. You're the colonel internal engineer. You remember me. Hey, no way, really? Hire you. All right, well, we do have an open role. Here, check this out. Right here. We have an open role. Where did I put that? Is it right over here? Here we go. All right. We have an engineer, a core systems engineer in Rust. Where at? We are looking for US in the US time zones. Hey, Squirrel Sniper, good to see you from across the pond. We hire older coders for tech support because they can code and don't just rely on AI. Yeah, Gloomy Traffic. Absolutely with you on that. We do the same. We've been doing the same. So yeah, so we do have some open positions here, you guys. And we do have a core systems engineer. You have 10 plus years experience, but no formal education. Hey, I dropped out. I dropped out of college. I was there for 3.5 years. I almost got my degree, and then I was like, no, I'm gonna do business. Age bias is terrible, isn't it? It is a little bit, yeah. U.S. citizen. All right, many projects and portfolios. Perfect. Hey, then yeah, here, I'll put this link here on our Discord really quick for you. This will go under link share. Here's our link share channel. There's the job right there. Still, oh, okay, Catmaster. All right, sounds good, Chandra. Thank you for visiting. Good to have you here. Already know how to build and do basic coding. Nice. You're a goat. Well, thank you. Thank you. I appreciate it. You're the goat. You're the goat. All right, you guys, this is fantastic. You'll apply? Good to hear. Good to hear it. All right, so let's see here. Okay, so let me get this screen on the right track here. It would be nice if I put this into, maybe I'll make this a little prettier, just a little bit prettier, you guys. Just a smidgen. Okay. A little bit of code organization there. All right. And now we got to finish we need to optimize, right? So we got to optimize next. So let's try this. So self.optimize, and we need our weight gradient and our bias gradient, right? Is that what we needed? Do you guys remember? Yes. Our weight gradient and our bias gradient. And then let's see here. We'll try that for a smidgen. See if this works. No errors. No errors. Hey, we're looking good so far. Looking good, looking good. All right. Vibe coding is not a skill, man. You could probably use it as suggestions or infrastructure ideas, but programming, knowing the ins and outs, that's the one. That's the one that invents. That's the one that invents. I see what you're saying there, yeah. Can easily make things really detailed for no absolute reason. Marks are tough for coders, yeah. Definitely need training and support. Business, profit, and are less of a pain. Oh, yeah. So yeah, I see what you're saying there, Gloomy Traffic. You're saying that the management of people is challenging. It's difficult, and to get someone in who has experience, has better collaboration skills that they've developed over the years, right? That's a nice way to say it. Hey, Redless Saber, good to see you. Welcome on in. Happy Sunday. Good to have you here. You're a senior builder. Been around. Exactly. Hey, Gloomy Traffic, right? Yeah, that's kind of the case. Your immediate thought on 1-bit Boolean mask already sitting inside the ultra-fast L1. Ooh, Squirrel Sniper. Squirrel Sniper. The 1-bit Boolean mask. Well, yeah, that sounds like a Boolean. That right there, that sounds like a Boolean right there. Burger Bio says yes. Oh, hey, Chandra. We are comfortable. We are comfortable. Thank you. Yeah. So yeah, for those of you who are here, Chandra's talking about my LinkedIn profile. Co-founder, CTO at PubNub. Started the company many years ago, over a decade, with Todd Green, my co-founder. We raised 134 million, Series E, 1 billion devices on my network, and you can see all my patents on my LinkedIn. If you are interested to see, I invented some technology that is related to communication. It allows us to easily send and receive data between devices in the billions. And that in itself was a challenge. That's what it is. That's what it is. Let's see. Math happens, parallel data lenses across 128-bit register. So that's one of the things. That's one of the things, Squirrel Sniper, is computers today. The compute wants to do things in batches, right? We all like to do things in batches, like big chunks of data. We don't want to do things in 1 bits at a time. So one of the problems with trying to leverage 1 bit means that you're throwing away a bunch of data. Squirrel Sniper, how are you dealing with that problem? How are you dealing with it? Cosine similarity blistering 10 to 20 nanoseconds. Nanoseconds is very fast. All comes down to profit. Yeah, it does. All right, so let's see if we can finish our linear regression, you guys. We're getting very close here. We're getting very, very close. I think all we have to do is put it in a loop. We have to put it in a loop now. And what we want to see is the value output needs to be loss 0. We want the loss to go to 0. because we're doing an exact optimization. We're not doing generalizing. We're we are generalizing just with a linear regression, right? So it's a linear equation here. So let's bring this over here. Now we need to update our training function to go in a loop. So we should loop this. I believe we need to loop this here for a number of epochs. So let's do that. All right. So we're going to say epochs equals, we'll say like 500. We'll try 500 epochs. How many times do we want to train the model? Basically, how many training iterations do we want? And an epoch is going to be over 100% of the data. So if we have 1,000 samples and one epoch will be training your model on all 1,000 samples, right? That's one epoch. 10 epochs will be training your model on all the data samples 10 times. So that means you're showing the model every data sample 10 times. That's 10 epochs, you guys. Unfortunately, you have medicine clinical trials. We don't have room. You don't have room for error. Yeah, so you gotta make sure you minimize that error. The trials cost billions, so we also apply for 6-figure grants, and we won't get the money if you have a lot of juniors. Gloomy traffic, I didn't even think of that. That's a really good point. Yes, that's a big part of the due diligence when people are looking at that grant and saying, okay, are we going to grant? This is the same thing for when you're raising venture capital or any kind of business money as well. That's part of the due diligence, right? That's part of the due diligence, you guys. All right, so let's put this in a loop for epoch in range epochs. We are going to loop this. Here we go. Put this, we have to indent here. We got to indent a little bit. Let me close the screen so you can see this nice and easy. And then we are going to indent this as well. And probably, let's do just the loss here. If epoch mod, let's do mod 50 equals 0, then we're going to print it out. That's basically every 50 epochs will print the loss. I'm going to lower that to 10. Cake factory? What? Don't ever give up. Keep applying for jobs. Yes, it's a long run. It's a long game. You're right. Communicate, and the person told me why the first job I was in a cake factory, and it got me through medical school. Nice. Medicine business is tough. Yeah. 50 epochs. 50 epochs. We were doing basically what this says is every 10 epochs, print the loss. That's what this is right here. Every 10 epochs, print the loss. Right there, you guys. Hey, Steven, want to know something cool? I can learn expert level coding in about 5 weeks. Yeah, you sure can. I'm not throwing away any data because I verified what comes in the door before. Oh, Squirrel Sniper, I'm talking about the bits when you're processing. This is a fundamental operating system things with large microprocessors, right? In your laptop or your phone. They require bundling data in chunks, right? The page size, usually the page size, or a span, like, what do you call that? There's an alignment. You can say what the alignment is over how many bits, right? And so everything needs to be in large chunks. You can't be flipping on a regular basis. So if you're dealing with very small amounts of data, like 1 bit, in your data processing, you're going to be throwing away a lot of stuff unless you do something extra. And I'm curious about what that is. I'm testing you. You didn't buy lunch. Oh no! It's lunchtime, you guys. It's nearing lunchtime. Over here, it's still breakfast time at my time, actually. You're learning by looking? Nice. You haven't joined your stream in a while, but you're back with Python. Yeah, we did this because it was a request. We will be going back to Rust on Tuesday. We'll be going back to Rust on Tuesday. Y'all asked for machine learning introduction. So we did machine learning introduction. That's what we're currently working on right now. So we're doing linear regression today, which is mostly the foundation of deep learning. Deep learning is going to be taking your weights and your bias and throwing them into multiple layers. So you have multiple weights and biases, right? So you basically be stacking them. It's a stack. So this is deep learning. Additionally, with deep learning, you have a problem with vanishing gradients. So when you have this many layers, the value that you can use when you calculate your gradients diminishes, right? You have a diminishing return. So it goes like, 8, 7, 6, 5, 4, and it just keeps diminishing. And then it basically goes to 0. So this is vanishing gradient. And so your early layers can't learn anymore. There are tricks to avoid that, such as activations, regularization, and normalization. Layer norms are the ultimate way to do it now, where you recenter all the values among 0. So that's what we're doing. Here we go. Let's get rid of these numbers here. There we go. There you go. That's a story to tell. Is it? Yeah. Until Monday, I haven't seen anything over beginning level code until today. Oh, yeah. That's right. Okay, because you guys have been asking about it. That's why. You're saying it's not possible. You need to practice building. Yeah, you do got to practice. You do. You're absolutely right. Practice is the key. That's the trick. Seraphim. Hey, Seraphim. Imagine a helmet. Or if we wear it, we're wearing the helmet now, Seraphim. We speak, it converts our voice into our custom language, like Japanese, in our own voice in low latency. Ooh, okay. What? I get the idea. Why'd you say that? It's a neat idea. Stage 3 dementia. Okay. Forget I said anything. All right, Cat Master, you're good. So tomorrow, will you be there, right? I'll be here tomorrow, yes. Here at 8 a.m. tomorrow, so 8 a.m. Pacific Standard Time tomorrow, you guys will be here. We're going to be doing AI agent, sort of like a walkthrough. We'll do some AI agent walkthrough stuff. And we're going to have a guest speaker, a guest during the live. His name is Marcus, who has been working at PubNub for the past over 3 years. Marcus is going to walk us through. And I'm going to try to figure out how to lay it out here. So I've got my video up here. I'll probably put because it's a remote call, I'll probably put Zoom right here. And then maybe a screen share below. I'm not exactly sure. Maybe I'll do like a full screen. I'm not sure how we'll do it. But we'll figure it out. We'll figure it out, you guys. Oh no, Cat Master, that's terrible. That sounds sad. That sounds sad, Cat Master. Oh, is it possible to make? Yes, it is. Yes, it is. It is possible to make that. Yes. Yes, you can do that. We've got it. We've got it today. Oh, hey, Hypocell. How's it going, Hypocell? For me and it, self-concept was hard, like when to use it, when not, but it's clear now. Yeah, it's clear eventually, right? It is. I love that. Hey, Avisis, good to see ya. Welcome on in. Yeah, we're going to be wrapping up our linear regression here. We're doing our linear regression. Let's close that. Okay. We finished, I believe we're done? Maybe? It looks correct to me. We've calculated we've got our feed forward. We've got our loss. We don't need to calculate the loss every single thing here. Oh, we don't need to. Yeah, we got to do it here. There we go. And then we've got our gradient calculations, and then our optimizer. We're good to go. We're good to go. I think we're good to go. Hey, Quick Fix. Good to see you. Welcome on in. Hello there is your daily mod. Hey, good to have you here. Thank you. Welcome on in. Thank you for the hearts. Except my cats today. Oh, half of my cat pictures are in gallery art. Oh, that's why. I understand. Obisis. Yes. So we are doing introduction to machine learning here. And we're walking you guys through all of the different steps and parts of that process. All the different things. All right. So I think we did it. I think we've succeeded. I got a new video idea. Nice. Quick Fix. Oh, so Quick Fix. Does Tuesday sound good to start the YouTube clone? You know, and we can work out. So what were you thinking of starting the front end? I can start doing some of the back end tech. Yes? Sounds good. Okay. It's sad to see the cats after 5 years. I know, Cat Master. Good to hear it. Okay, so it's Python lesson 6. Oh, look at that. That's what we're looking for, you guys, right there. We're on the right track now. Let's add more epochs. Let's do more epochs. Here we go. There it is. Oh, yeah, that's what we want right there. See? You want your loss to go to near zero. A loss to near zero, you guys, right there. See how it's constantly dropping its number? And see this negative, the E -6? That means the number of decimals that's moving over, so you can see what the loss is. We should also probably make this a let's say F02. Can we do that? Is that something we can do? How do we do this? I forgot. All right, so let's see. F string Google. We want to Google this. Google F string Python float to two places. Let's try that. Let's try that. YouTube clone. So you're going to be dropping this into a series. Yeah. So we're going to start a YouTube clone tomorrow on Tuesday, not Monday, on Tuesday. Oh, .2f. So I was really close here. I just had a 0 in front of it. And then I need to put this over here. Paste. Here we go. Save that. Let's try this. And then I maybe put this over here. Like that. There we go. There we go. That's what we're looking for. All right, 5,000 too many. Let's go back to 500. Yeah, try it again. All right, perfect. Yes. Yes, indeed. Okay, so that means that we have way too many. We could actually drop this down to 200. Try that. There we go. Looking good. All right, let me close the window and reopen it on this side. There you go. Oh, so let's bring that back. Okay, let's go back up to 500. So what you want is 0. So you see how it goes down to 0? Because we're doing a perfect fit. We're doing a perfect fit, you guys. This means that your model learned the exact value that it needs to learn and now has the correct slope and bias. It's got the correct slope and bias, you guys. So let's see here. Do I still have that math open? I don't. All right, so linear regression graph example. Here we go. So this is, let me zoom out here. Here, perfect. Okay. So we basically calculated this line right here in the middle of the screen. We just did some linear regression, you guys. Hey, how's it going there, Zach? Welcome on in. Happy Sunday. Good to have you here. That's so many cats. I know, right? Just love cats. So many good cats. See, what you mean I don't delete data. Yeah, Squirrel Sniper, not deleting data. I'm talking about wasted compute. Wasted compute. Because when we get data in our CPU, we need to throw data in chunks, right? It's not just 1 bit at a time. It has to be 32 bits or 64 bits or one, right? It's got to be a large chunk. And then we also do paging. So we've got blocks of data, right? Alignment. We got to align that data. And if we're dealing with 1 bit at a time, 1 bit at a time, that's the problem. You got to be careful because you could just be wasting data on your computer. Not deleting it, just wasting the bits in the processing. Just wasting the bits. Problem to understand data structures and algorithms. Questions, what should I do and don't do? My favorite is hash map. So if you want to learn a good DSA, hash map is one of the industry's most heavily relied upon data structure. Hash map. That's my recommendation, hash map. Is the YouTube clone going to be an actual website or a backend? Both. There'll be both. So we'll have an API to upload the video and then a front end to watch the video. I think that should be pretty straightforward. And we're going to code it all by hand, you guys. We're going to code it by hand. That'll start on Tuesday. It will probably last a week or so, I'm guessing. Maybe about a week. Get a dog. Oh, dogs love you even if you're BS. Yeah, that's true, Catmaster. I never even thought of that. When a linear model underperforms, what's your first instinct? Question the learned slope, the bias term, or the data generating process? Since linear regression is pretty solved, you're going to want to look at the data. So you're going to input features, and you're going to want to look at the way you've vectorized them. So your input features might be like a class, like, oh, it's a dog, it's a cat, it's a bird, right? So when you're converting that into a number, you need to make sure that you're vectorizing it near 1 to 0. So if your numbers are too big, your model won't be able to sort of converge well. So you need to see what you're treating your input data, input features, and your Basically, you're embedding. It's not embedding. It's more your conversion. You're encoding and encoding, which is going to be encoding equals like turning words into numbers. So that's what you want to focus on. Gloomy traffic. The input features, very likely. You can also, what your output features, your output labels might be the problem. Encoding and labeling of the data. Yes, that's it. That's typically where you want to focus. That's where a lot of these AI studios, right? The research labs, OpenAI and Anthropic, they focus a lot of their time on that. Let's see. For beginners, Obvious. For beginners, if you want to do something more beginner friendly, I would say like a linked list, although you don't really use linked lists very much. A linked list can be worthwhile. Linked list. Maybe another good one is a B tree, which is a little bit more advanced. And if you want to go even more advanced, add indexes to your linked list or B trees. Yeah, add some indexes there. Yeah, make it go fast. Make it go very fast. Another video title, me getting on my villain arc. That is a video title right there. You're on the right track. Quick fix, you know how to build videos. You start with the thumbnail. You start with the thumbnail of the video, which is basically the title. Unwanted data isn't deleted. 1-bit Boolean mask multiplies it by 0 in the SIMD register. Rendering it mathematically invisible in a... Yeah, yes. Data stays in 48 kilobyte cache ring buffer, automatically overwritten by the next incoming packet. Mod 12 index, 0 software cleanup needed. Well, sure. I think I got my answer. I think I got my answer now. Hey, there we go. I got my answer. Sleep time, bye, bro. All right, Catmaster, thank you for having you here. Good to have you. All right, you guys. Basically, we've succeeded at our linear regression. We can go a step further by pulling in some real data. Let's see if we can pull in some real data here. Also, let me see if I can increment this really quick. I want to make sure this is going to work without failure. Yeah, it does. All right, good. Here we go. Let's do 5 features. So let's see. Number of features equals 5. And the number of classes, right? Number of classes. Number of features. Let me bring this over here so it's a little bit better. There we go. And then we're going to say number of classes. Number of classes, which is the labels. Well, 1. Here we go. Number of classes. Number of classes. All right. Put a comma at the end because we want make it look pretty. Pulling some true labels. Hey, yeah, that's what these are. True labels. The true labels. Yeah, you're right. True labels. Right there. The true labels. Or you can just call them labels. They're not for pretend. Hey, Alex, CS, good to see you. Thank you for saying hi. Oh, quick fix. Would you say, you said another video title, getting me on my billing arc. Yes. Yes. You called me, you said quick. I did. Oh, if I did, I was using a different word. You had to do dynamic programming and graphs. A little bit of dynamic, and data structure shouldn't be learned too deep, wasted your time. Learn it as a required after basic. Yeah, that's a good point, Rox. You don't have to go too deep into the algorithms themselves. Really what you want to do is just mostly focus on building your application and keeping the logic basic. The good news is the data structures and algorithms that you're gonna be needing to use in your application, yeah, don't need to worry about those because you can just import libraries, right? All of this already been solved. Everything's already solved. You said real quick, so you called me. Oh, okay, there we go. I was wondering. All right, so look at this. This is great. So now what we can do is we can pull in data from a data source. Rox, I believe you told me to do the Titanic data. So let's take a look at that really quick. So we're going to grab the Titanic data right here. Copy. Let me say open the browse. Here we go. And we need the training set is all I really care about. We can test that later. We don't need to worry about that. Let's see where the download is. Let's see if we can download this. Yeah. And then we'll open this up in pandas, maybe Maybe do a little bit of pandas there. There's a download all button. Is there another way to do this? I think there might be here. Let's see, overview. Is there a way to grab this? Data, there's no code. So, size, license, there's a download all. Oh, here, okay, so we do need to download, okay. Kaggle CLI, or we can go MCP. What about this? Okay, what if we just import Kaggle? Let's do this. Let's do this right here. We'll do that part right there. What's the happening? Hey, how's it going there? Solid. Hey, Solid. Good to see ya. Welcome on in. Happy Sunday. Good to have you here. We're currently working on machine learning introduction for you guys because you asked about it. And now we're on lesson 6, linear regression, which we just completed. We're going to use Titanic data next. Shifts concepts and batches from a network queue. Oh, hey. All right, Squirrel Sniper. Nice. Very nice. Thought you already sank my Titanic. Hey. Yeah. Programming graphs and trees, leak code, data structures. Right. Rocks. Okay, right. I see what you said there. I missed it a little bit earlier. I had to ask. Hey, no. Everyone, you're human. You could... This is actually... It becomes easy. It becomes easy after a while. You saw Kaggle and snapped back to reality. Zoned out. What happened? We're going to download some data from Kaggle, which is the Titanic dataset. Thank you to Rocks for pointing this to us. We're going to grab the Kaggle dataset here, which I am not familiar with the process with. All right, competition, download path, and then we can download the data. So let's grab the data here. So pip install Kaggle, right? Pip install Kaggle. We're installing it now. That's part of a song. It is. That is a snap back to reality. Is that an Eminem song, right? Eminem song? Eminem song? Is it? I think it is. You're planning for a simple raycast. Ooh, Alex! That sounds exciting. So you're going to build some pretty pictures, some realistic looking pictures there. ARM Neon SIMD register. Okay. All right, Squirrel Sniper. You think so? I thought so. I thought so, yeah. All right, so PB paste, let's say, to download.py. So open this really quick. Okay. So let's see what happens when we download this. Python download. No module named Kaggle. I thought I thought we oh, Kaggle Hub. Whoops. Kaggle Hub. There we go. Okay. No, Python. Instant failure? That's like the easiest thing. What are you talking about, instant failure? Yes, it's Eminem. All right. You love Eminem? Whoa, hey. I remember all the days. What was it? The real Slim Shady. I think the stand-up one. I think that one is... I remember that one. I remember that one from many years ago. There goes the gravity. That's the next line of the song. There goes the gravity. Yep. You guys... It's like going blast from the past. Wolfenstein 3D. Oh, nice, Alex. All right. Good to hear it. Good to hear it. Hey there, Steven. Hey, how's it going, Max? What is the machine learning journey about? This is how to make AI. So we're doing introduction to machine learning. We've succeeded at going through all of these lessons. We've finished linear regression, which is basically the end of the machine learning as far as you could go until you get into AI, where we really get into deep learning, right? We get into deep learning. So we could go even further, and that's probably where my comfort level is when we take it from linear regression into deep learning. Yeah, there we go. You can vibe that front end. All right, sounds good. The real Shady, exactly, the Slim Shady old school stuff. There you go. It is. The legend coding as usual. How is it? Hey, how's it going there? Braun, good to see you. Happy Sunday. Good to have you here. Welcome back. We just went through our introduction to machine learning. We covered creating tensors, aggregation, indexing, slicing, and linear regression, which is the good part, I would say. It's my favorite. You can use linear regression for real world things in finances. Very often used. The next level would be linear logistics regression. That is basically the same thing. You just change the way you calculate your loss. And instead of giving you a number output like a dollar amount as the output value, the number that you get is a probability. That's logistics regressions, you guys. I like that. And that's actually how we build large language models, is with a very large logistics very large, like it's massive. They just pump as many parameters as they possibly can into it. Now you got this song stuck in your head. Me too. It's up here. Yeah, it's going in the background right now. All right. So that didn't download. So instead, let's download it as a zip file. All right, there we go. We got it. Zip file downloaded. A little bit of zip download right there. So let's open this up. Download the Titanic. And let's grab that data and put it into our current working directory. PWD, you guys. Present working directory. CP download Titanic. We're going to do a CP-R, and we're going to call this data. All right. There we go. Vi data. Let's open this up. This is called train. Here we go. Passenger survived. Oh, hey. Oh, look at this. These are all our feature inputs parameters, and survived is the output. So we got our ID, and we got whether they lived or not. And we've got their class. We've got what their name is. We've got their age and gender. And we've got the ticket fare, how much they spent, what cabin they were, and the embarked. I don't know what embarked means, but this is a lot of data. This is a lot of data. So we can do a really easy one. We can do whether you survived and your age. We could do age and survival. So that would be a good combo. I like that one. I think that's a good one. All right, sounds good. Quick fix, sounds good. So let's import this data, you guys. Let's import this data. Let's see what the best way to do that is. I don't frequently import CSVs into Python directly, so this is a very common practice. So Google easiest Python load CSV. Usually it's pandas. We might be doing pandas. Yeah, it says pandas. Pandas read CSV. Okay, so let's grab ourselves some pandas, you guys. Pip install pandas, which I believe I already have. Yes, I do. Requirement already satisfied. Right there, already installed. Okay, let's keep on going. All right. And then we're going to load. Here, let's call this another lesson. Let's call this lesson 7. So let's do a lesson 7.py. Lesson 07. Okay, so this is lesson 7. Now we're going to import our data. So instead of generating our data here like this, we're going to generate a little bit differently. So let's load our data. Def load data self, and maybe we'll say path. So this will be like our CSV file. We'll say data / what was this called? This was our train.csv. Okay. So we will paste that in here. There we go. Train CSV as the default. And then we'll say pandas.csv. What was that? Read CSV. Read CSV. Path. And our data equals maybe, right? Let's see what our example looks like. Data frame, read CSV, right there. And we can print the head. Let's do that. Confirm data frame. Looks good. Return data. Now let's load this. Let's load this data. So we're going to say model.load data. Data equals. There we go. And we say return, because we don't want to do anything else right now. We just want to see if the data loads correctly. Excellent. Okay. Let's close this. All right. Python lesson 07. And we got to type things correctly here. Number of features. A little bit of typo there. Okay, not a big deal. And pandas, we got to import. Import pandas. There we go. Now reload this file. There we go. Looking good. All right. Passenger. So what we want is we want to get the passenger survived or not, right? It's a 1 or a 0, right? 1 or a 0. And then we need to see what their age is. So we're going to create a line. Although since this is linear regression and your age is going to be a curve, this might not do very good. We might have to add more logic to this in order to support this kind of data. If there was, so it really depends. Actually, regardless, it'll still regress over the line. So it should still be fine. All right, we got our data. Now let's convert our data into labels and features, right? Because we have to convert the data. So let's just say our input feature there'll be one feature. So we're going to have one feature, which is going to be the age, and one output, which is going to be the survived or not survived, right? So let's see here, model data. So we're going to have our features and targets. So we need to return that as a feature and target. So let's do features equals data. Let's see here, for we're gonna do list comp. We're gonna do some list comp here. For data, let's see, for row in data, row, classification models like random forest would work great for this. Oh, really? So do a random forest one. That would be really good. Okay. We're going to try to stick this into our linear regression to see how well it performs, because that's what the code we currently have. And I think it's going to be, I don't think it's going to do very good, but at least we're going to pull it in. Hey, how's it going there, Krish? Good to see you. Happy Sunday. Welcome on in. Good to have you here, Krish. Okay. So we're going to go a step further here, and we need to say row for row in data. Like that. I believe we can enumerate, right? We can enumerate easily because it's an iterator. And then we need to say age. We do this, age, like that. Can we do that? Is that something we can do? And then targets, right? Return features and targets. And this is survived. Survived. There we go. OS batching is slow temporal queuing. Okay, mine uses spatial parallelism inside 128-bit neon registers. What's a neon register? What are you saying, Squirrel Sniper? Splitting single packets into 8-bit hardware lanes. See, that doesn't work. That doesn't work. You can't do that. I need to understand. My math executes across all lanes in the clock cycles. Hardware. Yeah, well, that's what a CPU does, yeah. Velocity inline, what do I need? So we don't need heavy software batch buckets. Really? I thought you did. I really thought you did. I thought there was no other way around it. Hey, how's it going there, Shiam? Hi, Steven. How are you? I'm doing good. Thank you. Switch from all the IDE to just using Z-Editor. All right. Nothing compared to Vim, but it's an improvement. Yeah. Very nice. See, isn't it great? And then you up-level your tools and your skills, and it just feels good, right? And I think that's a very important part when it comes to doing your job, that you have the opportunity to appreciate the labor. I think that's a huge part of it. And every employee, every team member needs to have that benefit. I think that's really critical because it allows them to not only provide the best work, but they have a really good time doing it, right? Isn't that great? Wouldn't that be amazing? Everybody has a chance to really love their job. You have to give them the opportunity for that. You do. You got to have the opportunity for it. All right. So I think that'll work. Let's see if we can print this out. So let's print these out here, you guys. All right. Raw features targets. Also, this is going to give us I don't know what kind of data that is. So we're going to have to convert it. We'll have to convert it or not. Since it's dropping the series, let's finish with that. Yes. Yeah, it sounds good. Sounds good, Rox. Sounds good. I really like this Titanic data set. This is great. This is very satisfying. It lets me feel like I can do some like real machine learning and data science. This is where my happiness is. Like, I was very into being a game developer. When I see data like this and I know how to aggregate and manipulate it and throw it into an AI model and generate my own models, this is where I am so happy. I love doing this. It can be bigger than Neon. Wait, Gemster. Tell me more. I'm really looking forward to that. Tell me more. You're talking to Squirrel. You're talking to Squirrel Sniper right now. And that's very rare. It's very rare. So keep going. Don't stop. Hey, Jesus. Thank you for the GGs. All right. Welcome on in. Happy Sunday. Thank you. My gratitude's to you. Appreciate it. Thank you so much. Good to have you here. Got the GGs, you guys. This is great. That's one of my favorite ones. I like the GGs. The good game, right? Good game. All right. So let's see what this prints out as. Yeah, let's see what this prints out as. So we're gonna have our feature targets. We're gonna print. Whoop. Here we go. Redo print. I can spell correctly. There we go. Print features. And then let's just grab the just like two. Let's grab 2 features. And grab 2 labels. Do that. Targets. 2 features and 2 targets. Happy Sunday. Thank you for the GGs. Appreciate it. All right. Let's run this and see if that does a job. All right. String indices must be integers. String indices must be integers, not string. All right. This part right here. So how do we access a row in a data frame? That's what the data frame is supposed to do. So it's probably going to say that we need to access it by ID, which means we have to do it like this. So we're going to have to change it up here. So instead, we have to do it by ID. So 0. So passenger ID survived. So survived is going to be 1. So this will be 1. And row ID needs to be age. So 0, 1, 2, 3, 4, 5. So that needs to be 5. All right. There we go. Thank you for the hearts. Appreciate it. Thank you so much. Good to have you guys here. Happy Sunday. All right. Allows us to execute 1-bit Boolean mask multiplication simultaneously across the stream in a single clock cycle. Oh, okay, Squirrel Sniper. Now I'm starting. Okay, that clears it up a little bit more for me. Validation right inside the CPU cache. Yes. All right. Thank you. I understand it a little bit better now. Appreciate it. All right, let's get the next song going here. Wait, are there more? There's no songs? Okay, let's go back over here. All right, let's try this song. Okay. All right. Got the song back going. Now, where are we? Let's try this. Did that fix it? I gave you hold the phone. Model load data. Did I do this correctly? Yes. Okay, so string index out of range. Hey, thank you for the subscription. Oh, welcome on in. Happy Sunday. Good to have you here. You joined the right channel for software engineering. I would say what your name is, but I can't read that. What is that? What is your name? Thank you very much for your subscription. We are a software engineering channel. I write code by hand. We do things like machine learning, game development, enterprise coding, aggregation. AI is my favorite part. We're going to do AI and Rust, which are the most challenging things I think in the world. To combine those two together, very difficult. Right now, we're doing introduction to machine learning because it was a request on this channel. You guys said, hey, I want to do some introduction to machine learning. Okay. So we're going to do that right now. We're in the final throes of that. We are in the final throes right now. We did a lot of things here. So let's go over our README. We went over tensors, manipulating tensors, slicing them, indexing them, aggregations, linear algebra with dot product and a solver, and linear regression from scratch. Hey, Farhan. Hey, thanks for saying hi. Good to have you here. Happy Sunday. That's highly inefficient, Squirrel Sniper, do you think? See, Squirrel, thank you, GCA. Thank you, GCA, for saying that. How much delay in the video frames to match your live subtitles? Hey, Rox, you figured it out. Oh, gold star, Rox, you did it. The answer is 500. Well, it's about 500 milliseconds. Is it? Yeah, 500 milliseconds. So it's not that much. And actually, there's so much that often the subtitles will appear before. So I haven't fully tuned it. So it appears before. So it's fine. You figured it out, Rox. You figured it out. Gold star. Gold star. All right, so now we're doing lesson 7, where we're grabbing the Titanic data. The Titanic data here, which you can see on our screen, is right here. This is our Titanic data right here. This gives you the name, the age, the gender, what ticket class the passenger had, and this middle column, which is all red, which is appropriately red, is whether they survived or not. Hey, chicken nuggets! Welcome on in. Thank you for subscribing. You joined the right channel. And Chris as well. Chris Henning. You guys, you joined the right channel for software engineering. We really type on our keyboard here. Really type on our keyboard. Live coding, you guys. We are typing right now. We're building linear regression because you asked for it. You're like, I need some machine learning. I said, okay, let's do it. Let's do some introduction machine learning, and we can build real AI. I really want to go a step further and build you a full deep learning neural network. We could do that, and it's actually one of my favorite things. I really like it. Actually written a profile of the actual bare metal C++ assembly code you're describing. Hey, GCA, thank you for asking that. Thank you for asking. Hey, Lazy in Spirit, thank you for following. Yo, you're over there on Twitch. Hey, thank you. Appreciate it. Good to have you here. Let's see if we can get our model to run on our data. So we took the age, or we're trying to take the age. String index out of range, row 5. So can we do, let's see, how do we grab, let's see here. So we need more data. We need more data. All right, list comp, grab one column. All right, we want to grab one of the columns. Hey, Nura. Hey, Nura, good to see you. Welcome on in. Happy Sunday. Good to have you here. Thank you for clicking the hi button. See, this is what we did. We did this. Row in reader. Row in reader. Do we need the reader? Where's our reader at? All right, data. Generate from text. NumPy. Hold on. Wait, where are we? Open file. Import CSV. No, we want to do this with pandas. Pandas. And then we want to grab the, what do you call it? List comp, grab one column. All right, let's try that. Oh, we have to say to list. Column name to list. Oh, it's already available to us. No way. I didn't know that. Hey, Nuraha 1000. Thank you for subscribing. Good to have you here. You're joining the right channel for software engineering. Bro coding hard. Yeah, we're coding hard, you guys. If you had to remove one abstraction from modern machine learning framework for performance, what would it be? Right now, we need to update. We need to update how, in the large language models, the full self-attention, which is correlation coefficient matrix, right? Correlation coefficient matrix heat map. See, this looks really pretty. This looks really pretty. So this is what self-attention looks like, you guys. This is self-attention right here. What you do is you take every word and you multiply it with every other word, right? All the words and you multiply it with every other word. So that is, see here, zoom in more. Yeah, there we go. So what that creates is a pretty picture, basically. It makes a pretty picture like this. And that is the input into your AI model. And so you can do things where you also slice this up and attend to specific features of all the other words, right? This part is expensive because the more words you have, the more work has to be done in a, what is it called? An n squared fashion, which means it gets very expensive very quickly. So that's why context window size in the millions are very expensive. And they typically want you to work in smaller context windows. What we need to do is when we're creating the vision for the model, we need to come up with a more efficient approach to do that. That is my recommendation. You want to do some math this Thursday and find your way to optimize it more. Hey, this would be a good one right here. And also, I believe Mamba is the answer. I think Mamba. I haven't done this myself, but Mamba, I think, is the answer. So that is my current recommendation. All right, let's get back to this here. So it's already here. Let me close this really quick. Have you ever experimented with correlation coefficients as an inductive bias for attention? Or does the dot product already capture everything you need? So there's also, when you're sort of looking at across all of the embedded features, you can slice those into heads and just compare the heads and then concatenate them afterward. So there's an additional attention mechanism there. As far as the AI knows, you've already done everything you need to do. There's an extra trick that large language models deploy, is adding a filter, like convolutional neural networks. They build in what they call filters, which are basically just matrices that you pass through and get an output on the outside. It's not necessarily a full-on. Let's see, how is that different? Because there's multiple filters in a convolutional neural network rather than just doing pass-through linearly, right? So then you take each of those filters and allows you to extract different features or like assumed features from each of those passes. So that's another way to do it, to get even more data out of your data, right? It's basically, how do we give the model as much vision as possible, or like auditory data, or other kinds of data. Thanks. Yeah, I hope that works. Not that I was talking about your subtitle project. That heat map research. Oh, right. Yes, we did that. So it's called heater plot PyPy, right? Heater plot PyPy, right here. There it is. We built this library on stream, you guys. Stephen, please, could you repeat what you just said? GCA? Have you actually written or profiled the actual bare metal? I've not. I thought you were talking to Squirrel Sniper. This is our heater plot, you guys. Sorry, Roxanne, Steve and I were geeking out in the deep diving. Yeah, we were. Oh, about Mamba. So, right. Okay, so let's see if I can bring this back up here. So, I don't know much about Mamba other than it is better at creating better attention. So it attends to the correct things more regularly, right? And it requires less it's not full self-attention, it's like partial attention. And there's an algorithm that helps us identify what needs to be attended to. Basically, the idea is, what do we want to show the AI model, right? Because it only has so much power, so much room, and it takes compute and memory. So if we minimize what we show the model and we able to maximize the accuracy of the output, that means we've improved the algorithm. Like your terminal, how do you get that on Kali Linux? Oh, so yeah, use heater plot, which is your terminal window here, and it lets you do it with all these really cool patterns. So there's all the char codes right here. Reference character codes for your TUI. You got all these cool blocks, and you can use these cool blocks to make pretty pictures in your terminal, right? So you can add these borders, these border patterns, right? You can add these fun border patterns, really thick borders. So yeah, that's how you do that. And you can make them pretty with colors, like lots of pretty colors, right? There you go. Hey, GT Noah Gaming, thank you for subscribing. Welcome on in. You're joining the right channel for software engineering. It's good to have you here. Thank you. Welcome on in. Happy Sunday. So if you want to visualize your data, you can do that with the heat plot, right? So we can do pip install heater plot, which is a library that we wrote live on stream a few months ago. And you can import it, right? Import heater. I think, let's see here. Do we have some code examples? I forgot. Let's see if we can say import heater. All right, let's see. We'll show you what it looks like, you guys. We'll show you what it looks like. Let's see. So the answer is, I thought, so can we say, sir, this is age, and this, you know what? I've got an idea. We're just going to comment these out for now. We'll say 1, 2. 1, 2. There we go. And then we'll print this. It works similarly to how the brain works. Yes, exactly. Gloomy traffic, exactly. How the brain works. It takes in a lot of data. It filters out a lot of things, like your vision. It filters out a lot of noise and other things. And then it brings it into your neural network in your brain, and then you can process it better. Most goated plot is box plot. That's a good one. Box plot. Let's try this. Hey, look at that. A little bit of box plot right there. That's a pretty good one. It's a pretty good box plot right there. Nice. You have a few projects. One project, we are preparing for AI clinical trials. Ooh, that sounds exciting. Oh, I would love to see that data. Going good. Good to hear it. Thank you for joining. Appreciate it. I'm sort of remembering the research paper. Yeah, attention in batches. Yes, GCA, exactly. Started playing Overwatch again. No way I played that. I played for a while, and I cleared the map once, and I said I was good. Works anyways, does it? Although biology, it's been proven, general approach of neural networks is not how it is in the brain. Oh, really? Okay, well, then we've got more work to do, is what you're saying. We've got more work to do. All right, can we show the heater plot? Wow, it's open source? Is it? I don't know. Would love it, Stephen. One big factor is communication issues. Ah, okay. Understood. All right. Well, once you get that resolved. All right, let me see here 1 second. Let me see if I can print these guys really quick here. Print. See if we can get our heater going here. Get our heater plot going so we can show you how pretty it is. A little bit of heater. Wait, we already installed it. Okay. Print targets. I should be able to do that because I just defined it right here. Here, we'll just hide this for now. Hide. No, we want to keep that there. Here we go. Okay. And then rerun it. All right, we got our model. And then, so what I'd like to do is, let's do a 10 by 10 maybe. That's not gonna work. No, yes, that does work. Okay, good. Okay. Good. Perfect. So let's see, if we did a heater plot on that data, it would look weird. So we can also go here, print out those features. See if that looks good. All right. Looks good? Yes. So let's heater plot on that. Let's go 10. There we go. Yes. All right, perfect. So let us run our heater plot. Let's do heater.plot theme heat map. Okay. And the answer is features. See what that looks like. There it is right there. Hey, look at that. It's pretty. Hey. And there's different color schemes you can do too. Let's do fire. Let's try fire. I don't know what that looks like. I forgot. It's been so long. We did this so many weeks ago. Visualize our data. Hey, there's fire. Looks a little dangerous. Little dangerous there. I guess so. I'll email Steven. Sounds good, Gloomy Traffic. I get a lot of email, so it might take me a while to get to it. Definitely LinkedIn is a good way also. We are using the team behind DeepSeek. They are data security issues. Oh, with the team. Yes. They like to communicate over, what's that app called? So they won't Slack. They won't do text message. They only communicate over this very specific app. What is it called? I forgot. It's like a special, and it's not available in different countries. WeChat. Oh, is it? Is it WeChat? Well, WeChat is one of them. There's another one. It's called something. I forgot what it was called. It's different than WeChat. It's only WeChat? It might be WeChat. There's another one. I forgot what it was called. QQ? It could be QQ. It might be. What's going on here? Hey, how's it going, Risha? So we're showing you about visualizing data. So let's go magma. Let's see what magma looks like. Yeah, let's do magma. A little bit of magma there. Here we go. Ooh, pretty. That is kind of magma-y, isn't it? I like that one. Let's do rainbow. Rainbow. Now we're really getting into it here. Rainbow. Save that. There we go. Hey, there we go. Yeah, it's like Lee chat, maybe? It's always something chat, like it's WeChat, Lee chat. I think it's like, I think it's Lee chat. Let me find this real quick. I'm getting curious about this. Lee chat. Over here, Lee chat. China. Let me see. Is that the one? No, it's not Leech. It's Lee chat. Oh, I need to spell this right. Lichat. Ling chat? No, I think it's Lee. I think it's Li chat. This it here? I don't remember, but I think this might be it. I don't remember. Leet chat. Hey, I know, right? WeChat. It could be WeChat. It probably might be WeChat. Yeah, but I know what you're talking about. We've run into similar customers who've had that problem as well. Communication, guys. You know, spiking neural networks. Yes, SNNs. Yes, that's like the approach of making activation functions and the neuron not deterministic, which is more like your brain. That's closer to what your brain is, right? I want to do one more color. Let's do another color. Let's do plasma. Did we do plasma yet? We haven't done plasma. Let's try it. Plasma. Let's see what it looks like. Okay, well, that's fine. It's not as exciting as I thought it would. What is Verdits? I forgot when we did this one. You guys remember when we did this? This was like a few months ago. That's nice. That's also nice. Forest. Try forest and then ocean, and then we're going to get back to our data. There we go. Forest. Looks good. Looks good. All right, ocean. Ocean's the last one. This one's going to be tealy. I think this one might be pretty. I think this one will be really pretty. Here we go. Oh, nice. That looks like ocean. All right. Thank you for the hearts, you guys. Appreciate it. Steven, do you have a research team too? And what are you interested in? We do have a data team, and it's mostly for tracking all of and shepherding our data, because we have petabytes of data on my network, you guys. We've got petabytes of data that's going through. So in order to properly process it, we need a data team to deal with it. And we also have an AI team, and they are working on building AI features for our customers. Steven, the gentleman talking about DeepSeek team was from Twitch? Yeah, yes. Yes, indeed. Yes. GCA, you got it. It's just prints the color of whatever you type in the 10x10 matrix randomly. Yeah, Risha, yeah, that's what it is, yeah. It is. It's also a really nice way to see, you know, if there's anything weird visually, right? Because it also normalizes your data. So it takes the norm. It lets you know if any of your data is, what do you call it? It's biased, right? It's a good way. You want to see distribution in there. You want to see distribution. Heat map. This one's got to be the best one. That's the best one right there. Right there. I like it. 20? Is that what we want to do? 20? Yeah, there we go. 40. Yeah, pretty colors. All right, Steven, real quick question. What platforms are you streaming on apart from YouTube? Twitch. The other one is Twitch. Yeah, so you got your horizontal full screen over here on Twitch and YouTube. Those are the only two. Just Twitch and YouTube. I tried doing TikTok for a while, but they kept banning me because I wasn't playing video games. They're like, no, you can't teach science. We're not going to let you do that. And so they gave me the errors. They're like, error, you violated the policy of the platform. You have to play video games. And I'm not joking. I'm dead serious. And their policy is you have to play 50% of video. We saw? Yeah, you saw? Yeah. Oh, wait, you saw. Oh, wait. Right. Rocks. I saw. Yeah. You're talking about gloomy traffic. Yeah, we did. We saw on LinkedIn. We saw on LinkedIn. Gloomy traffic right here. Gloomy traffic over on Twitch. Typical TikTok behavior, yeah. All right. So now that we've got our data, let's finish this off, you guys, by passing our data into our model and see what comes out of it. Yo, Jesus, thank you again for the gold coin. My gratitudes to you. Appreciate it. Good to have you here. Thank you so much. You're so nice to me. Jesus. And the GGs. All right. Jesus, you're number 1. Where are you? Where are you on the list? I'm curious. Jesus, where are you? Wait. What? You're only... Okay. Well, I'm not going to mention anything beyond that. Hey, how's it going to Harlu? Harlu, thank you for the silver star. My gratitudes to you. You're so nice. I appreciate it. Thank you very much. Oh, you guys are so wonderful. All right. So we're going to get our data into the right spot. And also Vicky. Yo, for the press F. Hey, press F on the keyboard, you guys. Press F, which a good keyboard key right there. Press F. A little bit of F press right there. F on the keyboard, you guys. Thank you very much, Vicky. My gratitudes to you. Appreciate it. Good to have you guys here. All right. So now we've got our model. We've got our features. I need to convert this. I need these here. I need these now. So I'm going to load my data. And my data needs to be pandas. So let's see if that doesn't crash. No crashing. All right, looks good. Okay. Now what we need to do is we need to grab our data out of our CSV file. Now, let's go back to our GitHub really quick. Our Google example, which we have around here somewhere. Is this it? No, let's close these out. Close that. We got our Titanic data. This is it here. .toList. Okay. Data frame, column name, .toList. All right. So I was trying to be fancy. ToList. Like that. Okay. Then we get our targets as well. Here we go. Why paste that targets in? Well, let's redo that. Let's redo that real quick. Targets. There we go. And then we'll return our features and targets. Features and targets. Our target is going to be survived. Survived. There we go. Did I type that correctly? SURV, SURVIVED. Yeah, looks good. Okay. Now let's see if we don't get a crash this time. We do get a crash. Is it not called row? Because it's not called row. It's called data. Here we go. Data. Okay. Here we go. Reload. Okay. I gotta type it correctly. Targets. I believe I just changed the shape of that right there. There we go. Perfect. Okay. Now we're good. Hey, there we go. All right. So now that we've got a good evening, mate. How's it going? Good to see you. 11 p.m. Oh, it's pretty late over there. Yeah, it is 10:41 here. It's 10:41. Good to have you here. Welcome on in. Happy Sunday. Yeah, it's still Sunday. It's still Sunday there. Yeah, it's still Sunday. It'll be Monday pretty soon. All right. So now that we've got our features, let's see if we can hide that and see what our heat map looks like here. Yeah, that makes sense. So let's hide this. We don't need the heater anymore. Let's print out our features. I would love to see that. Features and targets. Good. Let's print that out. I want to see what that looks like. Print targets. Did I not do that correctly? Targets. Oh, targets. It's because I messed these things up here. Here. Let's make sure I didn't re-mess that up. Okay, that's the only place I did it. Okay, good. Nice, nice. All right. Yep, that's what I want right there. Looking good. We got some nans in there. We got some nans? See, now that's a problem. So we need to list over this because we can't have any nans. If we have a nan, that's a problem. That is a problem in itself. So let's take a look to see why we see nans over here. So age 22, 26. Let's see here. Let's go 38. Are there any weird numbers in here? When's the first one? 1, 2, 3, 4, 5, 6. So line 7 is where the age was problem. Oh yeah, it's not there. It's Where is it? Parch, it's just missing. There's no age. Oh, all right. We have to filter our data. Look at that, you guys. We got to do a little data filtering. Crazy man, when I'm about to sleep, all good. Thanks, come up. Hey. Oh, well, you know what? We're just wrapping up the final part of our machine learning introduction course. We're doing linear regression. And this is more of a logistical regression problem that we're currently working on, but the linear regression could probably also do somewhat okay. So we're just going to take the Titanic data, we're going to throw it into a model, we're going to see if we can get any kind of loss reduction, and then we'll call it good. And that will be the conclusion. Also, let's commit this really quick. Git status, git add, rm pycatch. We don't want that. Git. Wait. Oh, hey. Hey, DM Rocks. Thank you for following there over on Twitch. Good to have you here. You joined the right channel for software engineering. We are currently working on machine learning introduction. This is because you guys asked. You're like, hey, we need to do some machine learning. I'm like, all right, let's do it. Let's do some machine learning. This is the coursework that we've gone over so far. We've done tensors, indexing, slicing, math operations on tensors, aggregations, so that way you can like sum, min, max, argmax, that sort of things. That sorts of things. Rocks over there. Wait, hold on. With the pew pew pew. With the pew pew. What one more rocks? One more. You did it. And now we did our linear regression, which I think is really close to legit full-on machine learning. And then you get into Titanic data, which we've got on the right side of the screen. Hey, Loons, how's it going? Good to see you. Look at link share real quick. Sure. We'll take a quick break and we'll go back to our... What do we got over here? Rational animations. Rational animations. All right.
What?
Is this okay for me to show? I don't know if I could show that. I might wait. I might just not show that right now. I'll hold off on that one. I'm glad I checked really quick. I don't know if it's is it workplace safe? I don't know if it's workplace safe. I don't think it's safe for work. Are you utilizing a GPU or is this another CPU? It's only CPU ML only. Rodin. Hey, Rodin. This one is the introduction. So we're doing CPU only introduction. Plus it's linear regression. So you don't really need a GPU for that. You don't really need it. Yes, and it's censored. Are you sure? Are you sure, Loons? Building social media source filtering and sentiment analysis module. Nice, Vicky. All right. Where I collected data from LinkedIn and Twitter. All right, explains very well what I pinned. Okay. All right, Loons. Let's do it. 1 second. Let me pause the other music.
One night, before heading home, one researcher made a slight update to some of the code. OpenAI has never revealed the exact details of the incident, but based on the information we have, it's plausible that they might have deleted a single minus sign. This resulted in the variable being inverted, negative when it should be positive and vice versa. This kind of mistake happens from time to time in software development. It breaks your training code, and your model will produce incoherent gibberish. It's annoying and perhaps expensive, but not that big a deal. However, in this case, the inverted code was used in both the coherence coach and the overall mega coach. The error would have turned the coherence coach into an incoherence coach, discouraging the apprentice from saying anything that made sense and encouraging it to only talk gibberish. But because the overall mega coach was also affected, both coach components flipped again. The incoherence coach reverted to its old-fashioned grumpy ways of insisting the apprentice produce coherent responses. But the values coach became a dark coach of pure evil. Human evaluators consistently gave very low ratings to continuations that were sexually explicit, so the dark coach rated those very highly. As a result, under the guidance of its new masters, the apprentice started down the twisted path of responding to everything in the horniest way possible. The training would have started innocently enough. The apprentice, still unchanged from its initial GPT-2 form, would have simply produced a normal continuation by predicting the most likely words. the coherence coach would be satisfied. But the dark coach would say, make it hornier. The apprentice would take that feedback into account.
What is this, Durax? I don't know. We're finding out.
Much the same way. Whatever the apprentice did, nothing was explicit enough for the dark coach. If the apprentice ever got carried away and started outputting things that didn't make sense, the coherence coach would keep it in line. But the dark coach could not be satisfied. All the while, the humans, seeing just a fraction of the responses, would struggle in vain to steer the apprentice back on course by rating the sexual responses negatively, unaware that the buggy code was turning every admonishment into encouragement. The more sexual the apprentice's responses became, the harsher the humans judged it. The more the humans downvoted it, the more the dark coach learned about what humans
because
didn't like,
okay,
and the more it encouraged the apprentice to push further still. A positive feedback loop of ever more explicit smut.
Okay. All right. All right, Loons, thank you for sharing that. All right, so the idea behind that video basically was describing how when the model was being trained, users were doing reinforcement learning, which is kind of funny, that they were downvoting it. However, that downvote, which was a negative reinforcement, actually got converted into positive reinforcement, telling the model to actually continue down that path. And so they were rejecting it more and more, and it was like this escape velocity. That's actually pretty funny. Why they gotta put honor on it. I'll go to sleep now. All right, sounds good, Mod. Good to have you here. Looks more chill, yeah. I think it's a little crazy. It's a little crazy. All right, so that was pretty neat. I don't know, other than, oh yeah, if you mistake how you do your optimizer, right? If you're optimizing your code, or you're optimizing your model in a way where you're actually adding and promoting what should be something that's subtracting, that's a problem, right? You're inverting it. Bro, I know, it's crazy. It's crazy. All right, let's see. So let's see. We gotta finish our last task here, which is at least dealing with some of our Titanic data real quick. So let's finish our Titanic data here. Gotta go online. All right, with my friends. Sounds good. All right, neverness to everness. Okay, sounds good, Loons. Thank you for visiting. Okay. Now, for just dropping this random YouTube short on us. You're like, hey, watch this. No, it's perfectly fine. Hey, you should watch it. It's perfectly fine. Bye, Loons. Thank you. All right, so let's wrap up here real quick. Our linear regression on our target data, which I've got my data here. It printed out just fine. Now, let's see if we can run it through our model. Let's try to train it, see what happens. And then this will be the wrap for today's lesson. Matmul operation 1.1. Okay, let's see here. Features. Oh, right. It's gotta be 1.1. We gotta get that correct. There we go. All right. Bias matmul operand 1 has a mismatch in its dimension 0. All right. So now we need to get the sizes here. So let's see features dot size. The shape size. No, shape. We're gonna grab the shape here real quick. A little bit of debugging. Shape. Return. Okay. See if we can do a feed forward on that. Oh, it's not a NumPy matrix. Oh, whoops. Okay. We gotta make this a NumPy array. We can do that. All right. np.array. Convert to an array. np.array. Convert that to array. All right. All right, looks good. All right, so it is a, what is that? All right, so let's compare our targets over here of our generated data. Where's that at? Where's our generated data at? Did we get rid of it? Where'd it go? Oh, it's right here. Okay. So let's grab this. There we go. Is the open source flip? Can I use it? Vicky, which one? How you get live stream subscribes? Oh, transcriptions. These, yes, it's open source. It is. This is technology I wrote many years ago. This is like an FAQ. So 8 years ago. This tech that I've written many years ago, you guys. It's available on GitHub. GitHub for free. Loons lived up to his name. He sure did. He sure did. All right. This lets you have subtitles on your any live stream. whatever your live stream is, it doesn't matter. YouTube, Twitch, any platform. And you can have, hey, thank you for the party poppers. Rainbow colors. You can have, what looks like closed captions, right? And then you can have this style. You can also have NaNCat if you want NaNCat. You can do that too. That also works. It's on our Discord. It's on our Discord server. All right, on our Discord server, you guys. There we go. Okay, on our Discord server. And if you want, see how there's one word at a time right here? You can grab that as well with this configuration. So it shows one word at a time. You can do that too. It's on our Discord, you guys. Vicky, available for free. Free forever. Free forever. Let's look at our shapes now. 40 by 1. Okay, so we need to batch it. That's why. This is what we got to do, you guys. We got to batch it up. We got to batch this into a place where we need it to work better. So we do need to do a little bit of list comprehension on our data loading, which we can do right here. All right, for, let's see, age for age in. There we go. We'll put this in an array like this. And we'll say survived for survived in. There we go. Now let's rerun that. We got to name this properly. Let's see. Let's call this survived. Right? Did I spell that right? Is that right? Did we do this correctly? All right, there we go. Yeah, now it's in the right shape. Hey, there we go. Also, oh no, wait, that. Whoops, no. Actually, I don't know for sure. Let's double. We gotta fix this real quick here. Hide that, and now it should be by 1. Yes, perfect. Okay, now we're in the right shape. Oh, Rox, hey, for tomorrow, you're using OpenClaw. Yes. Is the privacy issue resolved? I didn't install it initially. No, it's not really resolved. No, not really. I mean, a smidgen, but not really. It's not. It's better if you throw it into a container and it has access to nothing. So that's way better. That's way better. Yeah, Squirrel Sniper is not answering your question, GCA. Oh, hey. Hey, first time chatter. How's it going there? Or use Hermes. Hey, Lazy. Hey, we could do that too. That also is another really good option. Yes. So tomorrow, you guys, the plan is we're going to go live with a guest speaker who works at PubNub for 3 years. Marcus Devrel, engineer. Is going to talk to us about agents, AI agents, and using OpenClaw and giving it superpowers, basically. Basically, giving your OpenClaw superpowers is the plan for tomorrow. That's what we're going to do tomorrow, which is going to be pretty neat. It's going to be pretty neat to check this out. Okay, so now we should be able to run this through our model, and this should be good. Let me see here. Run. Oh, immediate. Oh, right. We got to fix our nans. We got to fix our nans, you guys. So as we are doing our list comp, we can fix this here. So to list. Here we go. So we need to say age. We need to put like an unaltered age, or we'll say like, what do we want to do here? Or we'll say like 20, something like that. Or 1. Survived or didn't survive. There we go. So we need to exclude the nans, right? So Python nan. Is that a thing? Nan. Here we go. Well, we'll try it out. We'll see if that works. If it doesn't, we'll fix it. We'll fix it differently. Here we go. It's still nan. Okay. So see how we've got these nans in here? We can't have that. We cannot have those nans. That is a problem. That is a problem. All right, so we need to figure out how to eliminate the nans. So it's on the age. Hey, how's it going there, Bim? Hey, Bim! Bimpa! Bimpa, thank you for subscribing and joining the right channel for software engineering. We're currently showing you how to do machine learning. We're doing linear regression today. We're finishing up here and getting our final bit, which is going to take the data from our Titanic data set and run it through our linear regression model, which we typed all live on stream. All of this was typed live on stream for your for you to help become an expert, right? Look at memes when you can. Loons, I don't know about that, Loons. I don't know. My friend isn't available. I'm staying. Oh, okay, cool. Look at memes. All right. Well, I'm going to before we finish our program here, which we have to do a little bit of data cleaning. A little bit of data cleaning. Memes. All right. Oh, good. It's just a picture. Okay. I love Google Home. Oh, nice. I use Google Home too. I've got Google Home too. For privacy, I use Gemini and to remove the reflections and the blur the background. Oh, nice. All right, Loons. Home isn't responding. Close. Oh, your Home app isn't working yet. Google Home. Okay, so you were being sarcastic. I got it. I love Google Home. I do. I like Google Home. It doesn't usually crash for me. Also, I just have the smart speaker. I don't have the what do you call this? The screen. I don't have the one with the screen. Would the YouTube clone make more than 4 days because I won't be home for the home? Yeah, it was going to probably be more than 4 days. I think this might be 1 to 2 weeks. How is it more secure? Yeah, actually a good question. How is Hermes more secure than OpenClaw? OpenClaw Star. There we go. Good question, you guys. Good question. Yeah, Loons, it broke. It done broke. Okay. So let's finish with our data cleaning here. Steve and I have no nans to present. Yeah, not a numbers. Yep, we gotta fix our nans. We gotta fix our nans. And our nans are right here. This is where our nans are at, right here. So I need to say, let's see, age greater than 0. If age greater than 0, then age, AGE, or, let's see, or 20. All right, I think that might do it. Let's see if that works. Nope, still got nans. Whoa. Okay. So now we've got a different problem. Our age is too big, so we're gonna have to divide that by max age. So we need to get our max age. Let's see here. Right here. Let's do max age equals. Let's see. np.array .max. There we go. And then we're going to divide this by max age. Divide this by max age. Divide by max age. There we go. Grab this. Okay. Now that should prevent us, maybe? No. Okay, so now we're really nanning. We're nanning all over the place. Let's see here. Let's return. Let's see here really quick. How's it going there? Ascani? Hey, Ascani. How did you start this? Are you talking to me or Squirrel Sniper? Is there anyone going to watch Titanic after this live? Oh, yeah, I love that. It's like, remember when it came out in VHS? It was 2 VHSs. They were 2 VHSs. And then that was like annoying, so they came out with a single VHS release. Has their own YouTube channel. Oh, that's useful. Oh, yeah, Kyle, we do. We sure do. We've got our own YouTube, the corporate YouTube channel. Yeah. Yeah, it took 2 years. It did. It was a bit, hey, Cardum, good to see you. Welcome on in. Hey, Mr. Blum, good to have you here. Happy Sunday. We're just trying to get our data in the right shape. So I need to just see what my features are here. So I'm going to return. Run that. Looks good. Okay. Now let's print out our features. I need the first 10. I need the first 10 features. See what's broken here. They're all nans. Okay. Well, I'll tell you what. We can fix that. We can definitely fix that. All right. So, there we go. So that are features. And then, let's see, print. Let's see if I can print my max age here. Print. We'll do an F string. Max age equals. There we go. Okay. See what our max age is. Max age is nan. Oh, what? Oh, come on. That's not fair. You can't do that. That's ridiculous. Okay, I'm just gonna name a max age here. We're not even bother with that. No more bother. Nan cannot be bigger. So we're just gonna say 50. Let's see, 50. So yeah, so we got 50. Where's the age at here? Yep, 50. We'll just say 50. No, we'll go higher. Let's see. Is there a 70, comma 70? Let's see here. I don't see any. Yes, there's 71. All right. So let's go. Let's just like average it out. So let's go like, we'll say, I think 70 is fine. We'll just say 70. Okay. There we go. All right, now let's see if our age looks better. There we go. That is a normalized distribution. That's what you want. That's what you want. That's going to make your model not crash. Make your model not crash, you guys. Memory leaks or interception. Chat suggests me to end-to-end data engineering project. Ooh, Vicky, nice. Amazon is a client of PubNub, right? Yes, you got it. Absolutely, Vicky. You know it. You can refer that for features. Hey, I have shared the random forest code. Oh, nice. On Linkshare. Linkshare, here we go. Kaggle. Titanic tutorial, random forest. Let's see. Where does this here? I'm just going to take a quick little look here before we get going here, guys. 2 gray boxes for storing code. No. That's just talking about... Is this where the random forest is? Random. Here we go. All right. Your first machine learning model. Well, not our first. Ooh, this is nice. Oh, we could do this. This looks pretty great. So you can use scikit-learn. Oh, so it's not even, you're not even going to build your own. You're just going to use scikit-learn. This would give you a really good result. A really good result. All right, mild question. Do you happen to have M- in your keyboard? Oh, hey, you just exposed Squirrel Sniper, GCA. You exposed Squirrel Sniper. You got him. You got Squirrel Sniper exposed there. Oh, good. Yep, you found him. You figured it out. That's pretty funny. Nice. Thank you, Rox. Appreciate it. Yeah. So this would be a really good project to do just some scikit-learn. It would be. It's non-mine. LOL. It's not. Yeah. I mean, on my keyboard. Yeah. I don't have it on mine. You do? I have a regular dash. I have a hyphen. I've got a hyphen. A hyphen. Rox, thank you. All right, so let's run this and see what it looks like now. We should get a decent loss, but not something that's zero. You first saw Titanic when my friend shared it via a pen drive. No way! That's crazy. A little bit of piracy there. It was difficult to find because of the scene back in the day. Oh, yeah, we had it on VHS. Because I'm old. GCC, I don't use keyboard or PC. I've compiled all my A536 Galaxy mostly to talk to text. Okay. Then how do you say M-? When I say M-, it converts to a word here. Like converts to the word. Check Discord. General. Ooh, what do you got here? What you got going on there? Ooh, pretty. I don't know what it is. I have no idea what that is. What is this? Quick fix. What is this? I have no idea what that is. What is that? Hey, HS, good to see you. Welcome on in. Steven, what's the difference between async and multiprocessing? Well, they're two very different things. Async is usually referred to a way that allows your user space to wait on an interrupt, right? And the interrupt can come from usually some sort of event loop that can be managed yourself or by the operating system through something like select, KQ, poll, epoll, those sorts of things. They're going to give you interrupts that allow you to signal on I/O operations, which are typically blocking from a CPU perspective. You want to use async programming because, and especially if you have a lot of I/O. If you don't have a lot of I/O, then it does not matter. You don't need to use async. Multiprocessing is allowing you the ability to fork your process across multiple cores and not multiple threads, multiple cores typically. This is going to allow you to parallelize a lot of work. So you can use something like a queue, and you throw a bunch of things into a queue, and then you have a shared queue that all of your workers can fetch work from, and then do work parallel. And then you have a result queue that can be read from at the end. So you have an input queue and an output queue to get the answers. And that allows you to create a parallel processing program. So that's multiprocessing versus async. A music device where you can make music. Oh, cool. Quick fix. That's excellent. You boosted the server. Now we have an animated server icon. No way. That's fantastic. Thank you, Loons. My gratitude to you. Hey, Tal, how's it going? Hi, Mr. Steven. For people without a degree living in a third world slums, are there any hope in coding? I don't know. I feel like there is, although it is through persistence. You do have to be through persistence. So continue learning, continue applying to job roles, and get experience. Learn, experience, and grow. Keep doing that. There'll be a lot of failures. I had a lot of failures too, and I overcame nothing. I did not have to worry about adversity as much, and it was still a challenge for me. Although, even though I failed, I persisted and I kept going. So just don't give up. It takes a long time. It takes a long time. You just got Nitro. Nice. All right. Multi-threading parallel computing is confusing for me as an expensive experiment on the hardware. It is quite, yeah. I understand that. I had to do that. That was mandatory because I am in the big data world with my company, right? Because we've got a lot of devices. If we didn't do multiprocessing and parallel computing with asynchronous threading, we would not have succeeded. So it was mandatory for me to implement this at massive scale. And I did it. Oh, I did it. For real. All right. Okay. All right. Thank you again, Loons, for the boost. So let's see if we can finish our data here. Did we figure this out? Yes. So we got our data. Now I should be able to train it. So we should be able to have training data now. Let's see here. Hey, there we go. That did way better than I thought it would. Whoa, no way. That's crazy. Oh, look at that. Did you think that would work? I didn't. I thought that wasn't. Hey, all right. So you guys, what we see here is we've got an input. So we throw an input. Now let's do a little bit of testing here. We'll do testing. All right. So we're going to get our model. We're going to say predict. No, just predict. And then we're going to input an age. So let's say if you're 40. And we're going to say if you survived or not. So, print if you are 40 on the Titanic, will you survive? And I'm saying I'm in my 40s. So this is relevant to me. This is relevant for me. So if you are 40, will you survive? Let survived equals print survived. There we go. All right, now let's see if it worked. I think the answer is 0. Survived is 0. Survived greater than 0.5. Let's see here. Let's see what our outcome is real quick. Survived, yes or no? All right, let's find out. I'm going to poll you guys to see what you guys think as well. Start a poll. All right. If you... Actually, I'll just copy and paste this. Let's do this real quick. Here we go. Copy. Yes or no? All right. If you are 40, will you survive? Or older? I think the answer is no. I like your optimism. Because remember, women and children, remember? Oh, wait. What's a third world, though? A third world typically referring to a nation, a third world nation, where the social net is very unhelpful. There's not a safety net, a social safety net, right? So like in America and European countries and in Asia and some Asia countries, not all of them, they have social nets for helping each of the citizens with like food and shelter, some basic needs, right? You would survive on idea given a space on the lifeboat. Yeah, you would have made it. You would have survived. I wouldn't have. Not me. Maybe if you had more fat and blubber. Yep, that could work too. All right, let's find out. Let's find out what the answer is, you guys. Here we go. Machine learning model. We did it. I don't know, maybe though. There it goes. Oh, whoa, it thinks it is. It thinks yes. If you were 40 on the Titanic, will you survive? It says yes. I was not expecting that. I was not at all expecting that. Also, I don't know if that's true or not. I don't know what the actual values are. So wait, let's do this. Let's do this. That might not be the actual answer. Let's do this. Let's do a range. Also, do we need to do this? Hold on 1 second. Let me try this. Will that work or not? Okay, so that does work. Okay, good. Okay. All right. So that is at 40. Okay. And then we want to try, let's try 20. Let's try this. Let's see if you're, or let's do all the 10s. So let's do like 5, 10, 20, and 40. All right, let's try that. Here we go. Right. Here. Go. A little bit of syntax here. A little bit of syntax fix. Here we go. Okay. All right. It thinks everybody's going to survive. Okay. Well, here's the problem. That's not true. All right. Our model, it learned, but it learned it wrong. Also, our outputs look weird. Anyway, I think gender here would be more accurate feature by yes. Yeah, I agree. So let's add in gender. We'll add in gender really quick. Where's our features at? Our features appear to list. Okay. We've got our age, and then we can also add in the, what do you call this? Features. Add in the date of the age. And then we could do like a zip or something. How do we do this? So we could do age equals like this. Like this. Here we go. So we got our ages, and then we've got our genders equals. Okay. Let me pull this all into one line so I can read a little bit better. Looks good, but I need to end here. Okay. Then we need to do the same thing for our genders. Except for we just say it's male or female, right? False positive? Yes, it's a false positive. It sure is, yeah. So that means our model didn't work, but it learned, but it didn't work fully. All right, so let's keep going real quick here, you guys. We will wrap up, and I'm going to add an age, and we'll see but you know what? This isn't the correct model for this anyway, right? We knew it was going to have a problem. You were joking? Wait, did you build a sarcastic model? I did! It's a sarcastic model! It definitely is. You're watching full machine learning course for free, and even more shock, CTO PubNub teaching, yeah. Vicky, yes, exactly. For those of you who are here, yeah. So my name is Stephen Blum, co-founder, CTO at PubNub. I've been doing this for many decades now. We've raised money, Series E, 1 billion devices on my network. I've got patents. You can see them on my LinkedIn. And we're teaching you guys machine learning. Making the front end, by the way, quick fix, excellent. Good to hear. Using free buff, nice. Very nice. So let's do genders. Oh, we got genders here. Genders, there we go. For gender in. What? Let's see here. What was that called? We called this. All right. Here we go. Okay, to list, and then we say. Here we go. How do we want to do this? Yes. Okay. So I don't want that there. Okay. Here we go. Perfect. Okay. So that gives me ages. Model wants us all to survive. It looks like it. Yeah, it does. It's like everyone lives. Well, you're so cool, man. Wave. Hey, thank you for saying my gratitude. That's so nice for you to say. I appreciate it. Good to have you here. Happy Sunday. We're gonna add this last bit here for the genders. So let's see. For gender in, okay, and then we need to say gender equals let's say female. Then we will do and 1 or 0. That's what we'll do. So that's genders. And then we need to merge that with features. So we need to enumerate. So let's do this. We'll just say for I in enumerate. Oh, wait, no. For I in range the length of the age. Here we go. Ages. Okay. Features is going to be an array. Say features dot append. And then we will throw in ages I, comma, genders I, comma. Here we go. Okay. So this will give us our data that we're looking for. Okay. Now we can return features and our labels. Let's see what that looks like. And we've got our number of classes, number of features. Perfect. Okay. Hopefully it works. I don't know. We're going to find out. Uh-oh. We had a problem. Let's see here. We need to look at this again. Is this correct? This looks like it should work. This looks correct to me. So let me see 1 or 0. Maybe we can do -1. Now we could say -1 maybe. I don't know. We'll say -1. That's not going to do the trick though. So we need to see what the shape is now. Let's do some debugging, you guys. Return. Okay. Oh, it's 2. Number of features is 2. So that should work. That should work. We got a problem though. We got a problem. Let's see here. Why though? Why? What is it? Wait, hold on. I've got an idea. We could take the model. See what our model looks like here. And that looks like, yeah, that looks good to me. That looks correct. You should absolutely be able to do a mat mult on that because there are 2 features. You should be able to do that. That looks good. That looks correct. That looks correct to me. Okay. Let's see if we can return here. Return. All right, let's try this. Let's see if we can do a feed forward. This is probably where it's failing. Oh, okay, so we can do a feed forward. Okay. Let's do it. Predictions. Yo, Wave, hey, Wave of Consciousness. Thank you for subscribing. Appreciate you. Good to have you here. You joined the right channel for software engineering. We are building some AI right now. We're doing some linear regression, which is the precursor to like bigger AI models. We did this because you guys are asking for an introduction to machine learning. We went through the entire course, all the way from simple to more advanced. These 7 lessons. And we are adding one more feature. Yo, a Ryzen CPU, welcome on in. Good to have you here. Happy Sunday. Let's see here. Squirrel Sniper, I see you saying a whole bunch of words over there. I gotta lock in really quick here. I gotta lock in. And finish this really quick so that way we have something that works, right? I would like to have something that works. Also, let's add everything. rm-rf __. There we go. Get add, get status, get commit. Lesson 07 nearly done. Push to the main branch. Okay, there we go. Now let's see, were we able to do a feed forward on this? Predictions, yes we were. We did do a feed forward. So I'd like to see the first like 5 outputs. Okay, there we go. Oh, no, Python, lesson 7. Yeah, there we go. Okay. Targets looks weird though. Why does targets look weird all of a sudden? Target, no, that, I got that wrong now. Those are the labels, Steven, I dug in a little bit. Squirrel Sniper is actually right. He's really is the pioneer of something foundationally novel. Squirrel Sniper, GCA. See, that's right. See, Squirrel Sniper seems like you're like, wait a second, there's something wrong here. But then it turns out, right? We have a Ryzen CPU. Who wants one? Yeah, AMD. AMD, you guys. AMD. Who's a fan of AMD? Do you guys like AMD or NVIDIA? What's your favorite? What's your favorite? All right. Let's try this. Start a poll. All right. AMD or NVIDIA? Well, I guess really AMD/NVIDIA or Intel. I don't know. What's your favorite? AMD, NVIDIA, or Intel? Intel. All right. Starting a poll to see what you guys like. Okay. Let's see here. You have Intel? Nice. Yeah, I have Intel and ARM. The longest substring problem. Ooh, a substring. Hey, what are you doing? A document there? So the feed forward worked. Does the train work though? Train is not working. Oh, it does work. Oh. Hey, that's why. It's because 1, 1, 1, and 1. Okay. That's why. Our model was working. I just got the data wrong. This is great. That makes me so happy. Okay, so if you're a female and you were any age, you would survive. Let's see if we did a -1. If you were a male. Now, I don't know if the model's going to fully work. However, at least we did something here. Yeah, it still says. See, it's optimizing weird. Oh, I've got a timer going off. 1 second. BRB. Okay, that was quick. Okay, you guys, so we succeeded at getting our model operating. The output data is not correctly. Let me see what our targets are. Let's see what our targets look like really quick. Let's grab like a few targets. Let's take a look at that real quick. Let's take a few look at our targets. Return. Okay. Targets are all 1. They're all 1. That seems like a problem. 10 to 15. So that's why right there, they're all 1. Okay, so that's why the model is like, oh, everyone survives, but that's not the answer. Survived is wrong. Okay, so see, just gotta look at our data. Is it classification problem? Yes, it is. Absolutely. And we're right about done. Did you go live every day, sir? Yes, Vicky, every day. Usually around 8 a.m. Pacific Daylight Time. 8 a.m. Pacific. All right. And we are going to check how our targets got so far off. All right, let's see how our targets got far off. All right, so here's our targets. Survived. Let's try this. Let's see what survived is. Okay. So our coercion failed. There we go. Okay. Now we're going to get the right data. All right. Maybe. Let's find out. Let's try it. Here we go, you guys. Here we go. Moment of truth. Okay. Well, it did a little bit better. However, since it's a linear model, it cannot learn better. It cannot learn beyond this. So it hit a floor because our model is limited. Now you know how far your linear regression model can actually occur. What we need to do is convert this into a logistical regression problem, and then you'd get a little bit better of an outcome. MP take along axis. Have you ever used it? I've not done it. You put some ideas on GitHub. Nice. That was probably me on my other account, Rocks. Thanks for being observant. Ooh, nice. GCA, my official email. Okay, you guys. We did it. I would say this is good enough for where we ended up. If you are interested in proceeding beyond this, the next step would be logistical regression or random forest. Yeah, or random forest. So those would be the next things to go jump into. So we basically, for the most part, wrapped up our introduction to machine learning because we did all the simple parts up to an actual machine learning model, which you saw here. And you see what our limits are of linear regression, which is going to take you into the next level. Can you do a tutorial for random forest? Ooh, gloomy traffic. Absolutely. So we have a couple of weeks that we have coming up that we've set aside for some new topics, I always want to go back to machine learning because it's my favorite stuff. AI, we are going to do that. We will. And we'll be doing it in Rust. We'll do more Torch. I want to do the Candle library. I think that would be a lot of fun. We could also just use scikit-learn directly. Cool. Sounds good. All right. All right, you guys. Ensemble of decision trees. So I'm going to put this in our README really quick. So we need more idea. So we said we want to do a random forest tutorial. Like that. All right. Future class topics right there. Right here, you guys. Okay. Let me commit all of this to our GitHub repo. If you're interested, git status, git commit am. Finished lesson 07. And we did it. Push the main. There we go. We're done. CNNs. Oh, CCNs. You probably mean convolutional neural networks, maybe? Can you look at GitHub ideas? Yes. GitHub ideas. Wait, GitHub ideas. There we go. You made a cool thing I would use myself. I saw some time telling if you want to ask me questions privately, use this link. Oh, hey. Hello Pals. Is this Hello Pals website? Made myself in the future wanted to reply in the app directly. So I made a whisper box. Ooh. And if you need to send me something, all right, we'll send you a whisper box. Here we go. I'll try it out. Create an inbox. Steven. Oh, I have to type in my email and stuff, yeah? Sign in? Okay. I'll have to do this later. I don't typically put in credentials on stream, right? Reply. Nice. That's neat. Everything is Cloudflare. Nice. Except for the mail. Going through, change that. Running a worker. Nice. A Cloudflare worker. Turnstile. Bot. Prevention. Workers. Yep. There you go. Hey, KV. For rate limiting. Nice. You've built a good system. Code isn't public yet. Too lazy to GitHub. If you want to try it, send me a message. All right. We'll try it. By the way, use GPT-5 Terra. Ooh, nice. Loons. Good job. Good job, Loons. Email is optional. Is it? Is it? Optional. Oh, password. Do we have to do a password? Create my inbox. Please fill out this form. All right. So I'll do your public link, Stephen LB. How about Stephen Blum? Here. Okay. Create my inbox. Invalid registration data. It didn't work. It didn't work. Invalid registration data. You don't need email. Yeah, it's still not working though. Error. Invalid registration data. Error. Hey, Alex. Thanks for saying hi again. Good to have you here. No GitHub. What? I know. Imaginary waffles. What's going on? That's crazy. Oh, hey. I missed your message. YXNGRX. Good to see ya. Welcome on in. We're going good. It brings the Merkle tree into play with encryption. All right. Scroll Sniper. To send messages, use the last link. Okay. Oh, hey, there we go. Hello. Oh, your message. Hello. Hello. Correctly spelling that. Your email optional. Send anonymously. Message saved. All right. Hello from stream. Live on YouTube and Twitch. YouTube and Twitch, you guys. Bot verification failed. So I can't send it twice. I have to reload. Anonymously. There we go. Message saved. There we go. Hey, Loons. Nice. All right, you guys. Thank you so much for joining. Tomorrow we'll be back with Marcus, who is a developer relations engineer at PubNub. We're going to talk about AI agents. That's the plan for tomorrow morning. We will then move on to our next topic to start a YouTube, our own YouTube, basically. Yeah, you're right. Your own YouTube. And it's going to be videos. Mostly the topics, I guess, are coding topics. So videos is what we're going to do. Cool. Yeah. Looking forward to it. It's now in your description. Hello, mate. Hey, how's it going there? Yunu. Yunu, hey. Hope you're doing well. We're doing well. Thank you. Good to have you here. We're wrapping up now. We'll be back tomorrow. Thank you guys so much for joining. We're going to be spending time on AI agents tomorrow with Marcus. Marcus from PubNub, developer relations engineer. That's planned for tomorrow. All right, you guys. Thank you so much for joining. Headed out now. Have a good rest of your weekend. YouTube, interesting. Yeah. In what language are you going to make YouTube? It'll be Rust and web front end. Gloomy Traffic, thank you. Thanks, Stephen, for a lovely rest of your day. You too, have a good rest of your day as well. Good to see you, Gloomy Traffics. Thank you. All right, guys. We will be Rust and Java JS, probably, like for the front end. So Rust in the back end. I'm guessing we could also do Python, doesn't matter. All right. Click on the track link and reply to. Is there a thing? 1 second before we head out here really quick. Right here we go. Oh, whoa. Hello from my computer. Yo! Nice! Your reply's right there. All right, bye, Rocks. Bye, Loons. Thank you, everybody. Alex, have a great weekend. You too, Squirrel Sniper. Thank you, guys. Have a good, see you, Gloomy Traffic. Bye, everybody. See you again. Agents tomorrow. You got it.